data that will help us answer the questions. You can see there are questions that are depending on that data. There is a graph to draw, up to 20 marks for that. So it's a whole practical that he's going to demonstrate for us. So be very keen, because without data now you'll not be able to answer any of the questions there. Okay? Yes. Now, which method of gas collection is this? Hi, Alvin. Alvin has. Good morning, Alvin. Upward delivery. Good. Pass me my iPad. So what gas are you anticipating for us to collect? Yes? Now, can you be going through the procedure in advance so that as he's doing it, you are not stranded wondering what is going on? Huh? Don't read the confidential instructions. They won't mean anything to you. Just read the procedure. Is there a gas escape? Hmm? So what are we investigating in that question from what you've seen? Pass me my book as well. I don't know if I can do. Okay. Let me see if I can pick it. So I pick the water. Huh? So, are we not supposed to have immersed it upside down with some water in it? So basically this is investigating effect of changing concentration on the rate of reaction. Are we together? Yeah.
Listen, how you open. This is what I said, the plane is. Okay, we need to postpone that activity for now. Okay? We'll just postpone it for now until we can make another delivery, upward delivery speed. Sorry? She's suggesting that it will be easier to deliver if we do not place it on this beaker. Placing it here. If we do,
just wanted to
it is still possible for it to work even when it is down. So we are going to make that again. Whatever has broken, we take it again. And then we'll continue. So let's do something else then. Chemical reactions, physical and chemical changes. Chemical reactions, physical and chemical changes. Now, what is a physical change? What is a physical change? A physical change is a... Can I give you a hint? Yes? According to me, a physical change is a reversible process. Are we together?
Yes.
Like when I wear shoes, I can remove them. That is a physical change. Okay? When I freeze water, I can melt it. So according to me, a physical change is a reversible process. Let me hear according to you. What do you consider to be a physical change? How would you define a physical change? other than being reversible. How else would you define a physical change other than being reversible? Yes? Hey guys. Yes? No chemical reaction happens in a physical reaction. Well, you can say that. Another one, physical reaction. I'm still under physical change. I'm still under physical change. Okay, let's focus to chemical reactions and see whether it's chemical change and see whether after defining chemical change we can get to. I just don't want to give you information and answers. I want us to come up with them together. Change. What is a chemical change? Sorry?
Can I attempt?
Yes, attempt.
Chemical change. It involves the formation and the breaking of bonds.
Chemical change involves formation and breaking of bonds. I agree. So you have described it through chemical properties, rather what happens chemically. Okay? Chemical change. Now, if a physical change is reversible, what about a chemical change? Irreversible. Yeah? Like when you cook an egg, cooking an egg, is it a chemical change or a physical change? It's a chemical change because you cannot reverse it back to where it was or back to its original state. There is nothing you will ever do that can return it back to where it was. So that is a chemical change. Another thing you can say about chemical change. Yes? Another thing you can say about chemical change. Chemical change. Yes, Sarah? Yes, new bonds are formed, but can you rephrase it and say that it leads to formation of new substances? Because that is actually what happens when a chemical change occurs, all right? Are you okay? Okay. Any other thing you can say about chemical changes? Nice. Someone in this room, a chemist, has said that chemical changes are permanent. All right? So, permanent meaning also what? Irreversible. All right? Are we writing? Gideon, are we writing? So can we go back to physical changes now? So we said that physical changes are reversible. Okay? No new substance is formed when a physical change occurs. No new substance is formed when a physical change occurs. No new substance is formed when a physical change occurs.
And we said it is reversible. Now, what signs? Now, since we started this lesson on Tuesday at a few minutes to 5 p.m., we have been undertaking a lot of chemical changes, chemical reactions. Now, what signs? We are writing here, not here. What signs are there that it's okay, the world is not ending, just transfer. Okay?
Yeah.
Yes. So what signs are there that a chemical change has occurred? What signs are there that a chemical change has occurred? Yes? Sorry? Yes, there is color change, that is number one. Signs that a chemical change is occurring. Number one, there is change in color. Number two, let me rest my back. Number two, yes, Chebi. Sorry? Change in mass, either loss or gain of mass. So some chemical changes lead to a change in mass. Signs that a chemical change is occurring. Yes, Cindy? Sorry? Increase or decrease in length or width. Okay? Haro? Change of? Change of chemical composition, yes. And that's why we see when we are writing a chemical equation, a balanced chemical equation, you find that there are totally different chemical formulas on the reactant side and totally different chemical formulas on the product side. Okay? Signs that a chemical change is occurring. Yes, Lenny? Sorry? Energy changes. Yes, there are energy, but is that a sign? Like, can you see or feel it? Or so you can say changes in temperature. Okay? Yeah. Changes in temperature is a sign that a chemical change is occurring. So when there is lowering of temperature, we call that endothermic reaction. And when there is rise of temperature, we call it exothermic reaction. Good. I'm looking for some other exciting. Do you have a Bunsen burner that is connected? Let me do one chemical change so that when you're giving me answers, you know what you're saying. Just one Bunsen burner. You're not giving me the exciting aspects of chemical changes. Yes. We are looking at signs. 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 Is that a sign or? Please move away. Go and sit over there. Ama ni walipue. That's a chemical reaction. Okay? And I've been asking you signs that a chemical reaction is taking place. You're not saying so. I've decided to do one. Then from this moment going, did you hear any sound being produced? Is that a sign? Yeah. Okay. I think all of it has hit. So have we formed a new substance? What else happened? What else happened? Was there a bright light? Thank you. Were there sparks? Were there sparks? Yeah, so those are the signs. Color change, sparks, a lot of light. Those are what we are looking for. Stop saying at your bonds. What have bonds done now? Leave bonds alone. Are we together? So let's sit and add those 2 points that we had not added. So sparks. Now, another sign that a chemical reaction has happened is that there is production of a sweet smell or a foul smell. When digestion takes place in your body, you produce gases. True or false? What did I say happens for you to get that gas? I want to see who was listening. Today, yesterday. Yesterday, I told you where the gas from your alimentary canal comes from. The one you call fat. Fat. That one. I told you where it comes from. Can I hear somebody explaining? Yes, 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 my dear. Along the duodenum. You are listening. So the bile salts contain sodium, hydrogen, carbonate, all right? That reacts with what? The hydrochloric acid from the stomach, releasing carbon dioxide, okay? Now, production of a gas is a sign of a chemical change. Production of a gas is a sign of a chemical change. So, go to the next page. Now, I want you to write 6 physical changes and 6 chemical changes. Now, I don't want you to write anything we do in the lab. Kindly note. Don't write anything we do in the lab. Write things you do in the kitchen, in the hostel, that are either chemical changes or physical changes. Can you start? And these ones should be applicable to you. this should be applicable to you. So these are not things you start discussing. I'm not looking for complicated examples. Hata kubomoa nywele na kushuka ni physical change. Because it is irreversible. It is reversible, I mean. Can we push ourselves another 30 hours? Huh? Yes. It is a voluntary action. You know, the way we say in coordination and response, voluntary and involuntary action. When you know that you are going to be walking on fire, you prepare your mind that is the fire. I do not have shoes. I need to get to the other side. So you just go and walk on the fire because you had prepared yourself. Are we together? Yeah. But if you are pushed to that fire without preparing yourself, you'll feel a lot of pain and you'll not manage. So just tune your mind a bit. Tell yourself, I'm not tired. I'm not sleepy. Huh? Today at 1 a.m. when I went for my break, I just started saying, I feel tired. I feel tired. Then I asked myself, what is this I'm telling myself? Huh? I started walking, saying, I'm not tired, I'm not tired, I'm not, and that is how I'm still here today. Up to now, I'm not tired. I'm not sleepy. Okay, Jessica? It's a game of the mind, trust me. The winning position. Now I want to hear the examples of physical changes that you have written. Alvin, sleeping and waking up. Is that a physical change? You're still thinking. You have overthought. Write what you've been thinking, please. Now, who has finished writing the physical changes and the chemical changes? Please, I need to hear those examples. I have taught many students, but I've not taught students who are performing tasks slowly like you guys. What's happening? The brain cells have been damaged? No. Okay, can I start giving you my examples? Huh? Shaving hair and growing hair. That is a physical change. It is reversible. There is nothing new formed. Are we together? It does not involve heat. There is no breaking or making bonds. It's a totally physical change. Now, if I were you, I would write all changes of states as physical changes. I'm helping someone, but maybe the person is not here. If I were you and I've been told to write physical changes, I would write all changes of states that I know. Sublimation, deposition. Huh? What else? Freezing, melting, evaporation, and condensation. All those are physical changes. Examples of chemical changes. Sorry? Is that? Oh, yes, Martin. Cooking. Good. Good example. Yes. Sorry? Sweating. Is there a new substance that is formed when we sweat? Mm-hmm. No. Is the sweat? No. The sweat is not a substance that is formed as a result of a chemical change. Because sweat is a mixture. Sweat is a mixture of the excess salt, is a mixture of fats that have been broken down. Okay? Is a mixture, so is a mixture of that has water and other things. So it's not as a result of a chemical change. For physical. Shivering is not a chemical change because you can shiver then just stop. Nothing new is formed. Now think about the signs I mentioned, yes? Chemical. No. You can vomit. It's true, yeah? Digestion is chemical because you can't take digested food and return it to look how it was before digestion. Respiration is a chemical change because it leads to production of a new substance. Now there's a sign I didn't give you for chemical changes. Okay? And that sign is formation of a gas. Formation of a gas. Formation of a gas. Okay? Gideon? Gidi. Wash your face. Formation of a gas. So anytime there is effervescence, are we together? Anytime there is effervescence, a gas is formed. That is a chemical change taking place. Other examples of chemical changes? Yes? Sorry? Chemical change? Ooh, no. That's a physical change because it leads even to evaporation, which is a change of state that can be reversed by condensation. Yes, Lenny? That is a chemical change. Anything that involves burning, combustion, that's a chemical change. All right. Now, when do we consider a successful reaction to have occurred? We have done so many reactions. Even now, I have done a reaction. Now, when do we consider a successful collisions to have? I'm even giving you the answer. When do we consider a reaction to have occurred? A successful reaction to have occurred. When do we consider a successful reaction to have occurred? Now, can you try and refer to my explanation on enzymes? You know, the good thing is that I'm the one who taught you the enzymes also. So I can tell you, refer to this. When do we consider a reaction to have successfully occurred? Okay, let's write. A reaction is said to occur when reactants collide with each other when reactants collide with each other breaking bonds and making bonds. Breaking bonds and making bonds. Now, the topic ahead of us, we are going to talk a lot about collisions. Are we together? We'll talk a lot about collisions. So that word collisions, start loving it from now. Are we together? Then, so what is the rate of reaction? What is the rate of reaction then? Rate of reaction? Yes? The speed at which a reaction occurs. You can also say it is the speed at which a reaction ends. Okay? So the faster the end of a reaction, are we together? The faster the rate of the reaction. You can also say that the rate of a reaction is the speed at which products are made. By the way, all these are explanations on rate of reaction. I've said number one is the speed at which a reaction occurs. Number two, the speed at which a reaction finishes. So if a reaction occurs and finishes quickly, that's rate of reaction. Okay. What did I say as number 3? Before Haron started confusing me. What have I said? Number 3, the rate at which the product is formed. And then number 4, the rate at which the reactant is. The rate at which the reactant is completely converted to products. Oh, ikalusi. Kunya maji. Kunya maji, okay? So speed at which a reaction occurs, speed at which a Well, you've written speed at which the reaction ends, speed at which products are made, speed at which reactants are depleted. So if I am reacting magnesium and hydrochloric acid, and it takes 5 seconds for magnesium to be depleted, then that can be used to comment about the rate. That can be used to comment about the rate. Now, it's okay. Now, based on those definitions that we have looked at for rate of reaction, then we can discuss first theoretically. Okay, we can discuss first theoretically the factors affecting rates of reactions, and then later on in the day we perform investigations that are explaining these factors that affect the rates of reactions. Are we together? Now, we start with temperature. Let's start with temperature. Yes, Haron? Yes?
By increasing the kinetic collision of particles that react.
So the moment you increase, I agree with your answer, very correct, let's clap for him. Now, he has talked about kinetic energy of particles. Now, if we can make particles move faster, Enoch, if we can make particles move faster, then we can make them collide with each other more, all right? And we can increase the number of successful collisions. Are we together? So the aim here is to make particles move, collide, and in the process have as many successful collisions as possible. Are we together? Yes, so let's comment about temperature. Increasing temperature increases the rate of reaction. Increasing temperature increases the rate of reaction. Increasing temperature increases the rate of reaction. Because this increases the kinetic energy of particles. This increases the kinetic energy of particles. I repeat again. Increasing temperature increases the rate of reactions because this increases the kinetic energy of particles, causing them to move faster and more vigorously. Causing them to move faster and more vigorously. Causing them to move faster and more vigorously. Increasing the number of successful collisions. 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 So of course, when successful collisions are increased, then the rate of reaction increases. Now I want to mention something so that when I start saying it, you'll not usianze kushangaa, why is she saying this? Now when we are talking about rate of reactions, it must be per unit time. I mentioned here another time that you cannot say that this car is traveling at 80 kilometers. Yeah? Have you ever heard what people saying at alikuwa anaenda na 120? Huh? Ever heard that? Yeah, that's a wrong way of describing a speed. A speed should be per unit time. She was driving the car at 50 kilometers per hour. Okay? So when it comes to rates of reactions, like now, for this one we can say, Alvin, take a break. For this one we can say that we have this number of successful collisions per unit time. Are we together? Yes. So in this case now we are increasing the number of collisions per unit time. If we were having 100 collisions every 2 minutes, then we start having 1,000 collisions every 2 minutes still. Are we still having an increase in the rate of reaction? Is there still an increase in the rate of reaction? Yes or no? I'm saying 100 collisions every 2 minutes and then 1,000 collisions every 2 minutes. Is there an increase in rate of reaction there? Yes, that's what I'm saying, that it has to be connected with a unit of time. Okay? Now, I'm going to talk about concentration, but we will not do an activity now, because this is the activity we were supposed to do to investigate the effect of concentration on rate of reaction. Bilha? So you're going to skip that, but we can discuss it. Now, how do you think increasing concentration increases the rate of reaction? Wanakemia. How do you think increasing the rate of reaction increases increasing concentration increases the rate of reactions? Evans, tell me. Huh? How do you think increasing concentration increases the rate of reaction? Talk about collisions. I know you know the answer, but it's just because it's still early in the morning. Sarah, even you have stood. One more night. But I promise the last night, I'll make it exciting. You won't believe it's me. Imagine. We will do very nice activities. Yes, Sarah. How does increasing concentration increase rate of reaction?
Maybe if you say like maybe let's say you have increasing the concentration, you okay, as
Oi.
I'm finding the right words to bring the
Okay, it's as you continue increasing the concentration, you continue increasing the reacting molecules, hence will lead to an increase in the production.
Nice. You're actually very right. Increasing concentration increases the number of reacting molecules, reacting elements, or like reacting particles. Are we together? So if I have the same volume, of 1 molar hydrochloric acid and 0.7 molar hydrochloric acid, there are more hydrochloric acid particles here than here. So when I put the same size of magnesium metal, it is exposed to more hydrochloric acid than here. All right? And that way, you find that there are more collisions per unit time because of the availability of more reacting particles. Okay? Stand up, all of you. Let us stand. We are standing. Yes. Lift one hand, the right one. Lift the left one. All right. Now move to the right. Oh, you're not even able to decide whether. Today be today. But I told you something, that when the sun comes out, the sleep hormone stops being produced. Did you notice that yesterday? Yes. Yeah, when the sun came up, we didn't even realize that it was, put your hands down. Did we even realize when we were getting to 11 a.m.? Yeah, that's what will happen, imagine. And then I told you that, yesterday I told you tonight would be the toughest night. You remember? Yes. I knew. Okay? I stretch like this. Is this girl stretching? By the way, if there's a student who has been strong, but today she has been subdued, is Bilha. If you look at her workbook, she has been working. Backward. How are you feeling? How is your back feeling? So you need to give yourself some self-talk. I'm telling you, it works. You do what? Yeah. Like, don't soothe your body. If you feel sleepy, wash it with cold water and stay alive, stay awake, okay? Let's be seated so that we can continue. The lesson is still on. The lesson is still on. Now, I need you to write that explanation for concentration on this page. You see this page, this space here? Yes. Please write the explanation for how increasing, this one. How does increasing concentration increase the rate of reaction? So we have said that increasing concentration means that there are more available particles for the reaction to take place. So there are more successful collisions. there are more reacting particles available, leading to more successful collisions. All right. We are moving on very well. Don't you think so? We're moving on very, very, very well. So, Miss, we have postponed this because the delivery, whatever, has broken. So he'll make another one. I can't wait for the sun to come up so that I can send you out to go and look for different types of soils. Then you come, we investigate the water retention ability of the different types. You think it will be exciting? Huh? Yeah, I know you just want to go out and feel free like a bird. Like an Eve. So there's this other investigation also that we will need set. The one for reaction of hydrochloric acid and sodium thiosulfate. It's ready? Can we do it or we are demonstrating? Ah, great. Can we go to investigate? Huh? Okay, let's have 5 groups. Can you imagine we are starting a practical at, is it 6 a.m. yet? Huh? What time is it? Ah, imagine the sleep is about to go, yes? Oh, okay, okay. So we are supplying you with hydrochloric acid and, okay, a filter paper and sodium thiosulfate. Now you are supposed to follow the procedure. Okay? No. Investigation 2. Investigation 2. Reaction of hydrochloric acid and sodium thiosulfate. We are supplying you with everything you need for that. Now this investigation that we are about to do now we are also investigating the effect of changing concentration on a chemical reaction. So you are going to check the time taken for the printed words on the filter paper to disappear. Now, can you be reading the instructions so that when everything has been placed on your desk, you just carry out the procedure? Now, you're going to do experiment 1, 2, 3, 4, and 5, okay? And make sure you collect data enough to fill that table. Now, if you have a problem, call me. I'll be right where you are. Let's do this. Can you allow some to come back? Like this. When you allow the ones who are outside to come, okay? Let's read don't read the confidential instructions. Don't read the CI. Just read the problem. Is your lab good? Wakoaje? Nakwambia the second night. Si mchezo. Tricky. Alvin. Kama utakomboa hadithi yako, utaenda live. Mse amestruggle. But we said I don't feel. Ambazo niambia na mkaniua. Tell me not to go for a break. You'd rather record somewhere and then recording that. You deduct from the two. It's telling me to go marathon. Like, okay, I can try. For the next like 6 hours. For the next 6 hours, like I do 6 hours and like forget how you like. And in short, you tell me to do 12 hours. If I need that, so that I feel those ones and then I
with experiment 1 now. If there's anything indicated that you need that is not there, kindly raise your hand. We'll supply you with it.
I'm telling you, I'm pushing myself. For God.
Work as a team, make decisions as a team. We need the data collected. Now, ideally, that practical plus answering questions is supposed to make to take a maximum of 30 minutes.
kindly share with me any challenges you may be experiencing? Any? Have you understood the procedure? Okay, start with experiment 1, we see. Okay. This is the investigation we are undertaking. Okay. Now, can we do experiment 1, or you're already doing it? Are you not swallowing? You're supposed to swallow the mixture. Kindly excuse, no student should go out. You can't be less than 10. We are now 12. Yeah. You can't be less than 10. Kindly. 45 seconds. Have you obtained data for experiment 1? Sorry? Where is the hitch?
Hi. I only have 13 students in class.
Guys, let's not take so much time in one activity. It's going to eat. We are supposed to finish that workbook. Huh? We are supposed to finish that workbook. Have you started the timer? Okay. Excuse me, where is the delay happening? By now we should be, or reagents? Now, as soon as you have all the data, let me know so that we proceed to the next thing.
Please go to the ambulance. Tell them to give you ORS for me. Put it here. Yes.
Okay. Where are those filter papers? Let me give this group. Choose another surface, please, that does not have spillage. Swirl. So you're supposed to look from the top. Are you seeing the position of the eye? Yeah, you're supposed to peep from the top.
What time did I start teaching after the break? The break.
I just want you to finish collecting the data. The rest we will do together, okay? Yes. Wow, you look so fresh. Huh? What has happened? What miracle has happened? Where are you recording the data? I don't see any data collected anywhere. What's happening? Please record it. Volume of aqueous thiosulfate is 50 for all of them, right? Is it 50 for all of them? No, it's 50, 40, 50, 40, 35, 30, 10. I feel like you guys, let's do together. Can we fill the first column? The volume of aqueous sodium thiosulfate is 50, 40, 35, 30, 10. And then we are using Okay, I think I'll suspend this activity again because we have taken more than 20 minutes trying to collect data. Guys. What is happening in this group? You don't have any set of data for over 20 minutes. Then join this group. They are getting. Join this group. Leave it, join this group and collect their data because we are just wasting time. Can you come and join this group and see the workability of it? Now, how many sets of data do you have? We have 50, 40, 35, 30, 10. The first one, volume of distilled water. Sorry? 0. The second one, 10. The third one, 15, 20, 40. So for all of them, we are using 10 centimeters cubed of hydrochloric acid, so no need to record that. What time did you get for the first one? Those are seconds. 99.5, 0. Okay, let's do the last one. Let's do the last one, and then we now move on to the questions. So, so there's something pending that I need to write there, which is reaction of HCl with magnesium, rates of reactions. Rates of reactions. Mr. Coco, was there a sample of gills? Was there a sample of gills? Gills?
Yes, yes.
Okay. Not now. I'm writing the investigations I want to do today so that we know and plan for them so that we avoid those time lapses. We avoid the time lapses for... Okay?
For the fish
Yes.
and the kidney,
Okay.
the heart, that is.
Sorry? I'm not even seeing. Okay, now, do we have all the data now? We are waiting? Okay. Now, please ensure that your columns are filled. Everybody, are you together? Because everybody is going to answer the questions and draw the graph. So ensure you have for volume of aqueous sodium thiosulfate 50, 40, 35, 30, 10. (50, 40, 35, 40, 10). Now, for volume of distilled water, 0, 10, 15, 20, 40. Now, please give me the last data. No, not yet. Okay. Yes. Sorry? It is going down because we've started adding water. This is time, Alvin, so it shows it's taking a long time to react because it's dilute. It's being diluted more. We're investigating the rate of reaction based on which factor? Concentration. So the more the water, the longer it takes for the reaction to take place. But there was no water here, so it was well, yeah, it should have been lower. You're sure it has not? You can still see it. Yes. It's the first one is 44, not 99. Okay. Now, do we have all the data? It's 44. Yeah. 44. Where is the rubber? Hey, Nyinya, kisibu me waste time. 44.50. Okay. Now let's settle now. The last one is? Huh? What? Interesting. Okay, now let's go to the question. Let's go to part B. Let's all go to part B. Now, are we having the same set of data? Okay. Now we are plotting the graph together. We are plotting the graph together. Let's be seated now. Let's be seated. Now what time has been taken for 50? 44.50. Can you plot that? 50 against 44 point. Now can we plot that data of volume of aqueous thiosulfate against time taken for the printed words to disappear? Keep plotting, keep plotting. Now, please don't stress looking for 71. Yeah? Like now, the one for 71, you just identify a place approximately where the one could occupy. Are we together? Yeah. Now, data 54.25. You can even do at 55. Yeah? Like even this one, 71.03 surely. I do at 71. So it seems we have gotten data for the fifth one that is beyond what has been provided in the graph. Sarah, are you sure you didn't take too much time to observe? Because if we cannot even plot it, then it means it's already wrong. Now, what is the appearance of the mixture in the conical flask at the end of each experiment? What was the appearance of the mixture? Huh? Milky? Milky white. Well, are you sure? I thought it was pale yellow or cloudy. Ah. Now, after finishing to plot, draw a smooth line graph. Right. I am coming to view your smooth line graphs. What are you calculating with a calculator? Hakuna kitu ya kucalculate. It is, every circle is 5. That's why 10 circles are giving you 50. Ndio? Yeah, you're a science student. Do quick mathematics. Okay? Now, because the last data cannot fit, just extend it up to where it will reach. Are we together? Yeah. Just be guided by the first 3. All right, let's go now to the questions. Let's go to the questions. Now, we said the appearance of the mixture in the conical flask at the end of each experiment is pale yellow. Okay? Now, part D, from your graph, are we together in part D1? If you're together in part D1, raise your hand. Okay. Now, from your graph, deduce the time taken for the printed words to disappear from view if the experiment 2 were repeated using 20 centimeters of aqueous thiosulfate. 20. So if when we used 40 we got 54.25, when we use 20 we'll get, what will we get? So you're going to go to where 20 is, and then draw a line up where the line touches the curve. Draw a line horizontally towards the time taken, and then sorry? Someone has found 125. Who else has found that? We should find almost the same thing because we had the same set of data, so our graphs should look the same. Evans. You see the sleep is disappearing. Who is that saying yes na nguvu hivyo, Alvin? I told you. Now I need everyone else to tell me what they are getting for D1, because we are all doing this. We are in this. Yes, Alvin? 140, how come it's different? Very different from hers, and we are using the same set of data. Allah, why is your, where? Oh, no, this was 44.5, not 99. That's why your graph looks like that. Please correct this. We read the wrong thing. Because I had also written 99. It's 44. Now, they did not say we draw a straight line graph. The instruction was we draw a smooth line graph, okay? Smooth line graph. You okay? Smooth line graph. Huh? Yes? Yes. Just following the points and touching as many points as possible. Why do I keep forgetting your name again? Javan. Or Omol. Javan. Diana. How are you? You well? Please draw the smooth curve. Now, what are you plotting?
I think I get the values wrong.
No, your values are not wrong. It's just the last value that was wrong. Plot with these ones and connect the line all the way to the end. Irongo, Miss Irongo. You have data. Huh? Now, let me bring you the data. Now, the data is this. Oh, ushapewa. Now, the last data is wrong. Please, the fact that it's not even within the grid, it's wrong. Please just ignore it. Join the points that we've been able to collect data for, and then allow it to go continuously all the way to the end of the graph. Do not consider the last data, please. There's no 390. There's no 390 in the grid. Sorry? Yeah, that's okay, because you've just done freehand, yeah? Yeah. Just do freehand up to where it will end. Now, I'm looking for what you've gotten for D1. That is why I stood. Please. Yes, Clarice? 135. 135. Sounds good. So which group is outside now for their health break? Huh? Okay. Can you give me the figure for D1? One last call, please. Yes, tell Lenny, Atikeli. Ooh. Okay. Oh, why did you? Okay. Okay, let me not dictate how you will extend, because I don't know if we would have gotten the right figure, how it would have been. Okay? Yeah, so for that one, let's just say it's a source of error. It's a source of error that we were not able to get. Yeah, and by the way, errors happen a lot in scientific investigations. Are we together? Did you see us yesterday trying to do a test for sugar, and the moment you put the food together with the Benedict solution, a reaction happens? Those are errors. Are we together? Yeah, and it happens. That's why we keep repeating and repeating until we have reliable information. Now let's continue with the questions. My book, please. My book. Thank you. D2. The rate of reaction can be calculated using the equation shown. Rate of reaction equals 1 over time taken. Now calculate the rate of reaction using your answer from D1. So using your answer from D1, just calculate 1 over the number of seconds you got. So if you didn't get D1 at all, it's tricky. Just take your calculator, calculate 1 over. Calculate 1 over, if you got 125, 135. And then let's go to E1. Record there. Okay, let's go to E1. In which experiment 1, 2, 3, 4, or 5 was the rate of reaction greatest? In which experiment was the rate of reaction greatest? Yes. Answers. Group 2 health break. Group 2 health break, please. In which experiment was the rate of reaction greatest? Yes? 1. Now, explain in terms of particles why the rate of reaction was greatest in experiment 1. Why was it greatest in experiment 1? Yes? Yes? Mm-hmm. Mm-hmm. We used 50 and we also did not add water. You remember? Yeah, so how do you put that now? You say that there were more particles of thiosulfate in a given volume. Aki yenyewe nikikuja nikipata you are not in part E2. Please. Flow with us. So the reaction was greatest in experiment 1 because there were more thiosulfate particles in a given volume. And that is why, so you can say because we used 50 centimeters cubed, as Bilha has said, and also because we did not add water. Thank you. Now we are in part F. Part F. Now give the name of a more accurate piece of apparatus for measuring volumes than a measuring cylinder. Again, give the name of a more accurate piece of apparatus for measuring volumes than a measuring cylinder. Now, choice of apparatus. Yes, Imelda? Burette, good. Any other? For measuring? How much are we measuring? Okay, you remember the pipette is specific to a certain volume, eh? Yeah, but at least the burette can give you a range of volumes and very, very accurately. Okay? Yeah, so you would have chosen the burette instead of a measuring cylinder. Now, part G, are we all in part G? If you're in part G, raise your hand, please. G. Can we read question G with energy? Read.
Suggest the effect on the results of using a 1,000 centimeters cube conical flask instead of a 250 centimeters conical flask.
Cynthia, do you have a different paper? I heard you saying 1,000. Or you said 100? Okay. So the effect on the results of using a 100 centimeters cubed conical flask instead of what? A 250 centimeters cubed conical flask. What would happen? Of course, the 251 is wider. So that means that the solution will be shallow, isn't it? But when you use the 100 centimeters cubed, when we use the 100 centimeters cubed, you're going to have shorter timings because of the depth of the solution. So the change, you will see the change faster in a smaller conical flask than in a large 250 centimeters cubed conical flask. And then now for H, sketch on the grid the graph you would expect if all the experiments were repeated at a lower temperature. Clearly label your graph. Repeated at a lower temperature. That means that the rate would have been lower, isn't it? So we would have taken more time to achieve that volume. Now, if this is the shape of the graph, so I've seen that most graphs are like this, isn't it? Yeah? So if we were using solutions of lower temperature, that means that the rate would have also been lower, isn't it? So there are high chances that the start would have been the same, okay, but would have taken more time. So more time means it's going to be above this, isn't it? Yeah. Would have taken more time. But the yields should have been the same. So this is the first experiment. And then this one is with the lower temperature. So you're supposed to sketch above the original curve to show that you are taking a longer time. So how was it? So one thing I have noted, I still keep saying, we are taking a long time to collect data in the investigations that we have been doing. I think it's important to work on that. Now let's talk about surface area. All right? Let's talk about surface area in relation to rates of reactions. Now for this one, I request for calcium carbonate and hydrochloric acid. No. Calcium carbonate and dilute sulfuric acid. Now, if it is possible to get of different sizes of particles, is it possible? Like bigger grains or bigger crystals and then powdered, is it possible? Ah. Okay. When you increase surface area, you are increasing chances of collisions. Are we together? You're increasing chances of collisions by offering more area for the particles to collide with each other. All right? Now, how do you now measure? How do you measure the rate of reaction when, for example, you're reacting different sizes of calcium carbonate and sulfuric acid? I'll use this as an example. Calcium carbonate and sulfuric acid. What are the products, first of all? Products of reacting calcium carbonate and sulfuric acid. Yes, dilute sulfuric acid. What do we get? Calcium sulfate plus water. Okay? So how will you measure? What parameters will you measure to indicate that the rate of reaction has increased when you have decreased the size of particles of calcium carbonate? Yes? So what are you measuring? What are you measuring? Because if you are performing an investigation, then there must be something that you're measuring. That's what I want to know. Yes? Amount of effervescence. Huh. How do you measure amount of effervescence? Oh, no. Sorry? Grams of sodium carbonate. For which one? For which investigation? Ten grams is enough. Yeah. Now how will, okay, now there are several things you can measure. Let's not waste time on this. The first one is volume collected, volume of carbon dioxide collected. Per unit time. volume of carbon dioxide collected per unit time. Are we together? So you are comparing, when I was reacting this type of calcium carbonate, I collected X, not amount, X centimeters cubed of carbon dioxide in this amount of time. Are we together? So are you seeing that now such data can be interpreted and you can be able to say and make a conclusion whether the rate increased or decreased with increase or decrease of surface area. All right? Now, another thing you can measure for this one is time taken for the calcium carbonate to dissolve fully in the acid. Calcium carbonate to dissolve fully in the acid. So for this particular one, we are observing time taken for reactants to be depleted. Time taken for reactants to be depleted. Are we together? Okay, guys? Time taken for reactants to be depleted. And then the third one, you can measure time taken for effervescence to stop. Time taken for effervescence to stop. Now, this one you're basically measuring the time taken for products to form. Time taken for products to form. Time taken for the calcium carbonate to dissolve fully in the acid. Time taken for effervescence to stop. So that one is basically indicating the time taken for the products to form. Now, which is the best method there? I've given you 3 methods. Which one is the best? I want to see. Which one would you choose? Science students, I want you to look at the 3 methods of establishing the rate of this reaction with surface area as the factor to consider, and tell me which method you would choose. Yes, Bilha? Time taken for the calcium carbonate to dissolve fully is what she would choose. Okay, time taken for reactants to be depleted. Well, it's a good choice, but it may not be the best. Yes.
Time taken for the effervescence to stop.
Time taken for effervescence to stop. Now, you will be sure it has stopped?
We will observe.
Is that the best choice we would have made? What if we considered the volume of carbon dioxide collected per unit time? I feel like that is very, very specific because it's actually using 2 measurements. It's using the measurement of volume and it is also using the measurement of time. So, I mean, the results there are quite dependable.
But for this other one, when you say, Bilha, time taken for the calcium carbonate to dissolve fully in the acid, what if you assume it has dissolved fully and there are some few particles that have not dissolved, you know? Now, when you say that time taken for effervescence to stop, so will you watch until the last bubble is produced? Yeah, so we'd rather just go with collecting volume per unit time. So this now simply communicates to you that in science, there are different ways that we can collect data within the same investigation. But we must learn how to make choices that will give us dependable and accurate results. All right? Yes. Miss, is there anything you have provided for us to use now?
Yeah.
Okay. But it's the same consistency? Yeah. So what we'll do, we'll investigate whether it is endothermic or exothermic, but we may not be able to compare in terms of surface area because we don't, yeah. Okay. So same groups, 4 groups. So we have provided you with calcium carbonate, 10 grams, and then dilute sulfuric acid. Okay, please rinse the conical flasks so that we use them. Now, you rinse them and remove the label for sodium thiosulfate so that you don't end up confusing. Make sure you rinse properly and then you have a clean one. Okay, give me this for the other group. Bilha, where are your group mates? Hey, how are these tabs? Kuna group iko nje? Let's wait for them to come. Alafu najua nini? Ukitoa huda, utaamka kabisa. It's all in the mind. It's okay. When they come, I'll give it priority. Okay. Now, I think we can use, if we are using these conical flasks, we can use 75 ml of dilute sulfuric acid. Can we remove the lab coats on top of the benches, please? Now, the person dealing with sulfuric acid should wear gloves. And then the other person should have a thermometer. So, at least one person per group. We are reacting a carbonate, calcium carbonate, that reaction over there. Calcium carbonate and sulfuric acid. One person should have a thermometer to check whether it is an endothermic reaction or not, or whether it is an exothermic reaction. So that means that we must measure initial temperature of the sulfuric acid. We must measure initial temperature of the sulfuric acid before we mix it with calcium carbonate. Who is? Welcome.
My dear students, can we remove those heavy sweaters we are wearing inside, please? Remove those heavy sweaters you're wearing inside. Yes. Just remain with the lab coat. It's warm enough. Apart from... Yeah. 75 centimeters cubed. Are you able to measure? You can measure using this. 75. Now make sure you measure the initial temperature. Can you measure the initial temperature of sulfuric acid and then rinse that thermometer? Place your sweater on the seat and then do the experiment. By the way, we are not placing clothing on. If acid spills on it, that's it. By the way, you know you can sit on those sweaters once you're done. Eh? Most of you are complaining about the stools. You can sit on the sweaters. Still okay. Still So I want the initial temperature. I want the initial temperature for sulfuric acid, and then I want the final temperature once the reaction has stopped. Now we already tested for carbon dioxide. Do you remember? How did we test for carbon dioxide? Someone remind us how we tested for carbon dioxide. Yeah. It was just the other day. Wasn't it yesterday, yes?
You introduce a burning experience. It will distinguish that burning.
Yes, that is a method, but it's not unique to carbon dioxide because there are other gases that can distinguish the flame. Are we together? So which method did we use yesterday? Yes. We tested for carbon dioxide using exhaled air. Yeah. We're using 75 ml. And this is 10 grams. Have you measured the initial temperature of sulfuric acid? Please do. Because what we are investigating here is we are not just mixing them for them to react. We are checking whether it is exothermic or endothermic. No, it has already been measured. It is 10 grams.
Okay.
Yes.
Shake the body up.
Well, can I have the initial temperature? 25 degrees. Now check until you can't see any more change in temperature. You don't have to wait for the reaction to end. It's until you don't see any more change. And then, is it going down or up? That's definitely an exothermic reaction. Concert at 28 from? Good. So you can record that and now that can be recorded under the subtopic surface area. Although I had intended for us, okay, we have used the same carbonate that I had indicated there, and then the same acid. That is the balanced symbol equation, including the state symbols. Now, you'll include the 3 methods of collecting data when you are using different sizes of the particles. Are we together? And then now, you're also going to write your findings, the initial temperature of the acid, and then the final temperature after you have reacted the acid and the carbonate. All that in that space, part C. Is there anyone who has not understood the instructions? Should I repeat the instructions? Yes. Okay. I'm saying, since we have done this investigation, we have just not used different surface areas. Are we together? But you're going to write the balanced symbol equation, the 3 ways in which you can collect data to check the effect of surface area on the rate of reaction. Are we together? Yes. And then now you're going to write the initial temperature for sulfuric acid and final temperature and indicate whether it is endothermic or exothermic on that space. Yes. Bila, we are together? Put the thermometer inside so that you start seeing the changes. Is that 75 centimeters cubed of acid? Please add. Just add. Approximate. Okay, that's enough now. Stir. So you don't have to wait for the reaction to end until you stop seeing any more change in temperature. How long will that take? 3 minutes? No, we are not performing any investigation now. We are writing. We are writing. So after we are done, I'll want to discuss the presence of a catalyst. Are all the groups here now? Group 3, raise your hand if you're in group 3. Go for your health break. Not a prolonged one, okay? Yes. So the rest of us, let's finish writing, and then we look at the presence of a catalyst in relation to the rates of reaction. Are we okay? What was your initial? Huh? Final is?
Final is 10:30.
Okay. So, what do we conclude about the reaction of the carbonate and the sulfuric acid? Is it exothermic or endothermic? Exothermic. Because the final temperature is higher than the initial temperature. Now let's discuss the presence of a catalyst. Presence of a catalyst and the effect on the rate of reaction. Now, when we are talking about catalysts, we always refer to activation energy. Do you remember activation energy? Now, a catalyst does not really fasten a reaction. Are we together? Contrary to what we always say. But what a catalyst does, it lowers the activation energy and ensures that that reaction requires the least amount of energy to start. Okay? So if I have two investigations, A and B, two similar investigations, and I use a catalyst on one, and I do not use a catalyst on the other one, it will take a longer time for the reaction to start for the one without a catalyst. So probably that is what makes that statement to be made, that a catalyst increases the rate of reaction. That's not really what it does. What it does is that it ensures the reaction starts as soon as possible by lowering the energy requirement for that reaction to start. Have you ever looked at it that way, by the way? You have? Yeah. I feel uncomfortable when people say that a catalyst speeds up the rate of reaction. That's not it. So what a catalyst does is that it reduces the activation energy. So reduce my many words to two sentences and explain how the presence of a catalyst affects the rate of reactions.
This one. When I decide if this one is high.
So have we finished describing the effect of the presence of a catalyst? Okay. So remember, there is one investigation that is pending, the one for reaction of HCl with magnesium ribbon, where we are investigating the effect of changing concentration of hydrochloric acid. So just leave, you can even fold that page so that you remember. We'll come back to that. Now, activity 1.71, we already did it. You remember? Where we were testing for water of crystallization using hydrated copper sulfate. And we were able to achieve a similar result with the secondary data. Was that nice? Yeah. So next we are going to look at equilibrium. Equilibrium. Now, before I even talk about equilibrium, I'd like you to note that equilibrium can only be achieved in a closed system. Equilibrium can only be achieved in a closed system. Now, can you put the sulfuric acid away, please? Put the sulfuric acid away. You don't want spillage of acids here. Now, how do we describe equilibrium in a closed system? What happens when we say that we have achieved equilibrium? I want to hear your views. Yes.
Let's say when there is a zero change in energy.
When there is zero change in energy, meaning that it's the same energy being used to break bonds. That's amazing. You can add that point. When there is no enthalpy change.
When the rate of forward and backward reaction is equal.
Yes. When the rate of forward reaction equals the rate of back reaction. Now, where are you writing? We are already in this other page. We already did this investigation. So we are at dynamic equilibrium. That's what we are describing. Now, when the rate of forward reaction and back reaction take place at the same rate, we say that we have achieved equilibrium, a state of dynamic equilibrium. Now, when there is no overall change in anything, are we together? Even when you put a thermometer in that reaction, you don't see temperature rising or falling. Then we have achieved dynamic equilibrium. All right? Now, another pointer to dynamic equilibrium is when concentrations of products and reactants remain constant. Now, choice of words there is very important because I see students saying are equal. I'm sure you have ever made that mistake at some point. Yeah, so they don't have to be equal. They may not be equal, but the concentrations are constant. The concentrations are constant. So what we started with remains the same as we proceed. So there is a description there for chemical equilibrium and a graph that is also describing that. Now you can see where the two graphs have met, the forward rate and the reverse rate. That is where we say equilibrium has been achieved. Are you seeing that graph? So with time, we'll have a different forward rate, a different reverse rate, but at the point they join, it means that's the point that we have been able to achieve equal rates, and that is the point of dynamic equilibrium. So there are two industrial processes I want us to discuss that are based on equilibrium. And the first one is the Haber process, and the other one is the contact process. Now let's look at the Haber process. Now the Haber process involves production of ammonia using nitrogen and hydrogen. Now why should we produce ammonia and the way it smells bad? Why should we produce ammonia? Now, ammonia has several uses, and so its significance cannot be ignored. Are we together? Now, the first use of ammonia is to manufacture nitrogenous fertilizers needed for plant growth. So that means ammonia is very useful in agriculture. Are we together? We were studying about the importance of nitrogen in plants, and we realized that nitrates are important because they help in making proteins, and proteins help in growth and development. All right. Now, B, as raw material for the manufacture of nitric acid. Ammonia is a raw material for the manufacture of nitric acid. Someone read for us, C. As cooling agents in refrigerators. D. To produce ammonium chloride used as an electrolyte in dry cell. Continue. Next.
Make synthetic fibers such as nylon.
Or those who have pretended or those who have pretended to have fainted. And then the last one is making of explosives for different purposes. Are we together? Yeah, it's good for me to mention that. Okay, so where do we get the nitrogen for this process? From the atmosphere. What percentage of nitrogen do we have in the air? 78%. So, I mean, this particular reagent is readily available. Okay? Now, and where do we get hydrogen? This is where the problem now starts. We get nitrogen from natural gas such as methane. So, there is a balanced simple equation there for production of ammonia. Now let's talk about now the conditions that are necessary for us to achieve equilibrium and also achieve enough yield of ammonia. So you see this industrial process, the aim is to get as much ammonia as possible. So we must look for means and ways and manipulating the conditions that we are giving this process so that we end up with as much yield as possible. Now we have the Le Chatelier's principle here that states that if conditions of an equilibrium are changed, now I'll start by explaining temperature. Le Chatelier's principle states that if you change the conditions of an equilibrium, the position moves to the opposite change. Now, for example, when you lower temperature, the equilibrium moves to the exothermic direction. Are we together? So if the forward reaction is an exothermic reaction, and then, so it is producing heat. Are we together? And then you add heat, it will go back to the endothermic side. Okay? So you always try to do the opposite. So if you want to favor the forward reaction, which is an exothermic reaction, what do? You lower the temperature. All right? Now, let's talk about pressure. Now, when you raise pressure, the equilibrium goes to the side with fewest gas molecules. Are you seeing it's doing the opposite? Because you would think that when you raise pressure, it will go to the side that has more gas molecules. Now, when you lower the pressure, it goes to the side with most gas molecules. So depending on what you want to collect, you can decide whether to lower the pressure and move the equilibrium to the side that has most gas particles, or vice versa. Okay? Now, concentration. Now, when you decrease reactant concentration or increase product concentration, the equilibrium moves to the reactant side. Increasing reactant concentration or decreasing product concentration, equilibrium moves to the product side. Now let's look at how equilibrium can be shifted in the Haber process. Now I won't discuss this first, the two small illustrations there, but I'll go to now the temperature. All right? Now, in this reaction, will raising the temperature help you obtain more ammonia? Because I said earlier that the industrial process is for what? Is for obtaining ammonia. Okay? Now, one thing you need to note is that the forward reaction in the Haber process is an exothermic reaction, meaning it gives out heat. Now the back reaction is endothermic. So we are targeting the forward reaction. All right? So what are we going to do? We will lower the temperature so that reaction. Okay? Now if you increase the temperature, in this case, you are basically encouraging the equilibrium to shift to the left, and that will mean that the ammonia you are forming is being broken down again back to the reactants. Are we together? Now, changing pressure. Now look at the equation. Which side has more gas molecules? Someone? Evans. Which side has more gas molecules? Sorry? No. Based on the symbol equation on the board, which side has more gas molecules? Just add the number of moles. Sorry? Is it the reactant side or the product side? The reactant side. How many moles does it have? Wait, I'm asking him. Yes? Okay. It's okay. Yeah, so now, in this case now, increasing pressure would favor the forward reaction, isn't it? Because the forward reaction is the one that has fewer gas molecules. And so, we try to balance these conditions to ensure that we get the highest yield possible. When you increase the pressure, the equilibrium mixture acts to oppose this. and so more ammonia forms, which means fewer molecules. Now, another way of making sure that we are shifting the equilibrium to the right, to the product side, is by point number 3, by removing the ammonia. Now, basically, when you remove the ammonia from the product side, you now create a demand for more ammonia to be made. Are we together? And then, lastly, number 4, you can shift the equilibrium to the right by doing what? Adding a catalyst. Now, unfortunately, when you add a catalyst, it affects both the forward reaction and the backward reaction. So as much as you're adding a catalyst, it can't be the only thing you've done. You should add a catalyst and also make sure you manipulate the other conditions so that you get the optimum conditions. You get the optimum conditions for the best yield of ammonia. Okay? So I think we can look at a question. We have problem 1 there about hydrogen and bromine. Now you're using the principle of equilibrium, the Lachatelas principle. Are we together? Now hydrogen and bromine react reversibly to form hydrogen bromide. Now which one will favor formation of more hydrogen bromide? So we have 4 parameters there. Will we get more hydrogen bromide when we add more hydrogen, or when we remove bromine, or when we remove hydrogen bromide as it forms? Yes? I can take now for 10 minutes. Where? They want me to take a break. Oh, at the road. I've done 4 hours. I've done 4 hours from 4 a.m. I want to take 30 minutes. I want to do up to 10 a.m. I want to do up to 10 a.m. 10 a.m. I'm going to wash them. I'll go do. Okay. Are we attempting problem 1? But I'm not seeing people writing, discussing. Anyway, what did we get for A? What did we agree on for A? Remove the hydrogen bromide as it forms. Can you do B and C and then we discuss? Okay, are we done with B and C? Explain why increasing the pressure will have no effect. I'm interested in hearing the answer for this one. Please write the answer down. That's why there's space to write. Hey, we are writing. Damaris, you okay? Okay, time is up for that. Can we discuss B and C? I'm interested in hearing your answers for B. Jessica? Huh? Louder, please. For this particular reaction. So is that your answer for B? You haven't answered the question though. The question is asking you, why is it that increasing the pressure will have no effect? But you are telling me the effect. The question already tells you that there is no effect when you increase the pressure. So they're asking why. Jelimo, you seem like you have something to say. Sorry? Okay.
I think from the reactants and product side, both moles, we have the same amount of moles.
It's a good trial because it's the right thing to say. Okay? Yeah, so there will be no effect because we have the same number of moles of gases on the left and the same number of moles of gases on the right. So pressure now is not a factor to consider here. Okay? What is C asking? Sorry? The pressure is likely to be increased. Suggest the reason increased when the reaction is carried out in industry. Suggest a reason for this. So it seems we are increasing the pressure for other reasons, but not for reasons of shifting the equilibrium. So being an industrial process that is dealing with gases, why should we increase the pressure? Yes?
To increase the contact between the molecules that use from our products.
However, the pressure is likely to be increased when the reaction is carried out in industry. Oh, yes. Now, if we are dealing with gases, if we are dealing with gases, and you know the nature of gas particles, the way they can randomly move and scatter, we have to compress them. First of all, for ease of storage, and to bring them closer to each other for what? For the reaction to take place. Also, this equilibrium can only be achieved when it is a closed system. Okay? Yes. Now, before I go to the contact process, I want you to dedicate another 5 minutes to your project, the one you are making the heart. Where is it?
Is there an extra minute?
Yes? Is there extra? Was there extra? Whose was this? Maston, where is yours? The heart. So give it another 5 minutes. Let's see. So let me bring you the sticky notes to... Why can't you use something like glue and I don't know what you can use to thicken these walls more instead of just drawing lines? I'm not aware whether there was more plasticine. It's okay. It's okay. So. Ndio hii. Nataka kwenda hadi saa 4.
You'll make it. I'm here for you. Okay, Facebook. Ile harvest group. Harvest. Ukapasia kuja haraka sana. Maswali ya chini.
Namwambia.
Nilikwenda kuambia kwa habari mpya.
Oh no. 3 minutes to go. Can I see how the photos look like?
So nice.
You plan to put them in your website?
Yes. So what we'll do, I will come and talk to you because we need consent. We'll give her our consent form, sign, so that we will put your photos. You know, you can't just put photos. You neglect the issue. You know that these officers that are protection in the yes. So when you seek consent, I'll bring for you a consent form, and then unaweza mpea kwa breaks. I've not managed to talk to you because the break is so short. Some of them look like the same. You can see. From day one. So because we don't have the partnership between has with the students, that's why I'm taking activity based.
Yes, you cannot take their faces.
I can't take their faces. I can only take hers as much as possible and avoid taking. This is how the photos will look. They are more activity based activities. I like where you are. I can see you visibly, but I can share with you the photos. Yes, I'll share with you the photos because I'm sure you have an agreement with the learner.
Okay. But I'm going now. I'm going for a break to take a shower.
One more minute and then we put it aside. We'll continue with it later. Yeah. Or this side, yes? Sorry? Yes. Okay, let's put the models aside and proceed to the next thing. We are 30 minutes away from 40 hours. And we finish tomorrow. Yeah. Amazing. Huh? That is ready. Okay. All right. How many are they? Has it defrosted? Okay. Yes, I will. Okay. Now let's put the models aside and dissect the heart of a goat. Wow. Imagine. Ew. When you're a scientist, you don't get disgusted by... Kindly clear a bench for me. Please clear a bench for me. Yeah. So we want to see the... Yeah, you can dispose them in that dustbin. Just don't pass in front of the camera. Okay, please let's put aside our models. Yes, here. It's okay. Okay, can we come closer? Let's come closer so that we So I want you to identify the parts of the heart as I dissect it, okay? Now who can quickly remind me the parts we talked about early in the morning at 4 a.m.? Do you remember what we learned at 4 a.m.? Some of you are looking at me with one eye. Eh? Huh? Fabian?
Yes.
Good morning.
Good morning.
Okay.
We start with the corona.
Now, just by observing this, what do you see?
Fresh.
Huh?
Fresh.
It's fresh. Nyama fresh. What is this? This is a muscle. Are we together?
Yes.
And then what surrounds the heart? Fat. We have this fatty tissue. And what is the purpose of the fatty tissue? Do I have all the students here?
Yes.
The ones that are in. Okay, the rest have gone for a break. Huh? Yeah, so I'm going to dissect it. So this is the lower part of the heart, all right? And this is the upper part of the heart. We don't have the big scalpels. Now, you see these are now, this one is the left side of the heart. How do I know it's the left side of the heart? Are you seeing this thick muscle?
Yes.
Yes? I want to just open it up. Here we go. So we'll try as much as possible to observe something, okay? Now, what are these? Okay, these are just blood clots. So this being the left side and this being the right side. Now the blood vessels, this one has a big lumen. Are you seeing?
Yeah.
So this is the vena cava. Okay? Now, what are these? Pulmonary arteries. Okay? Why are they two? Why are they two? It's a pulmonary artery, yes. You see, it exists as one. Are you seeing? Are you seeing? It actually exists at one, but here it, not to increase surface area. No. Because one takes blood to one lung, okay, and the other one takes blood to the other one. Okay, deoxygenated blood for what? For oxygen. Yeah. So when you look at for the right side, it's thinner. Are you seeing? Compared to the one for the left side. Now this being the left side, so we have said this is the vena cava. This is the pulmonary artery, but it has split into two so that one can take blood to the left lung and the other one to the right lung. The left side, identify using the lumen. Now, this one has a big lumen, and you can see it is also joining the heart too, okay? From this direction and this direction, and then joining and entering there. So right now, this finger of mine is actually in the left atrium. This finger is in the left atrium. So, yes. The mic is off. Put it on there. Okay, so how I know that this is the pulmonary vein is because of the thin walls. Are we together? And the big lumen. That's how you know. Are we together? Now, why is it joining us two? From each lung. Now you see you are becoming surgeons. And then now we have the aorta. This is the aorta. So this is the pulmonary vein joining. So my finger right now, this one, is in the left atrium. Are we together? And then this is the aorta, which is now exiting. It's here. This is it. This is the aorta. It's thick. It's thick because it has to pump blood to the rest of the body. Are we together? Yeah, so this is the right atrium, this one here. Okay. Sorry, left atrium, left ventricle. Okay. And then this is the right ventricle, and then this here, I've not cut it. Yeah. Let me cut it and show you. I show you my ways. Ooh, there goes the chamber. There goes the chamber. So, there it is. Are you together? Yeah. Now, are you seeing this? These are connective tissues. Now, in between the left side, actually I cut through the septum. I cut through the septum here. there's a septum that prevents mixing of blood on the left and the right. Okay? So this is the right atrium, this chamber here. Okay? And if you now see, I'm able to access the external. I want you to see. You see? Because na cover, okay? So I've actually, my finger has gone through the right atrium, and then now I'm able to access the vena cava. Are we together? So this is the vena cava, pulmonary artery. Okay? Any question? So this is what we were doing at 4 a.m. Only that we were describing the human heart. But the mammalian heart actually has the same features. Now I was saying that the heart is a muscle that requires nourishment as well. So we have the coronary arteries that are lining the muscle. So these arteries, when they block as a result of, poor diet, smoking, all those things that we talked about, that's when now this whole muscle is unable to contract and relax as it should. All right? And now we end up getting things like heart attack and all these things. Okay? Yeah, so any question now? So all these that I'm touching here, all this is the right atrium. Can I stop now? Are you seeing this? The way they are, these are valves. Okay? Yeah. They open downward. Then when blood wants to go back, they close. Yeah. And this muscle is very, very hard and strong. That's why the heart cannot burst. Have you ever seen something that scared you and your heart beat and you don't burst? Yeah, it did not burst because of these strong muscles. Okay? Any question? We are okay now? All right. Thank you. That heart was so cold. My fingers are even freezing. Now, we want now to look at the gills. Okay? Or you're tired of looking at animal matter? No. Okay. We want to look at the gills of a fish And I want you to come ready with your eyes. I told you to be taking pictures with. Yes. Be taking screenshots with your eyes. So the moment I start showing you the gills, I want you to look out for. That's okay.
It was scratching.
Okay. Okay, let me have some other lungs. Lungs or gloves? Yeah. What else should we dissect? Frog? Are you sure you'll sustain? Or you'll run away? Okay, now this is an animal that is a fish? Is that what we said? So it is in which class? Okay. Pieces or pieces? Okay, now, before I even open it up, can you give me the adaptations that you can observe? Alvin. It is streamlined to enable it
to glide in the water.
Hey, you are listening. Yes, Jessica?
The scale facing backwards racing assistant.
Yeah.
Can you say it has an operculum covering the gills?
Operculum covering the gills for protection. Now, the scales facing backward, away from the head. What does that mean for movement? Yes? Yes, they actually reduce friction and decrease resistance. Are you together? Yes, Clarice?
We have a tail for propulsion.
Have a tail for to help propel it in the water. Aaron?
We have veins.
Veins. Oh, fins.
That enable them to float
And move in the water. Okay. Just say anything you can see. Anything you can see is an adaptation that...
I have a question. What about this line? Is it the lateral line?
It is. This is actually the lateral line.
for sensitivity.
For sensitivity. Good. Another adaptation. Compound eyes. Simple. Compound eyes are only for insects. Okay? Please, let's not overthink. We said we will not overthink. Yes, that's what I want to do. So, because they live in an aquatic habitat, why am I feeling guilty? Cutting it like this. It's not alive. Okay? Now, I don't want to dismantle this thing beyond this point. Eh? First of all, I don't want to touch the eye. I don't want to. So these are the gills, eh? Now it was frozen, but at least you can see the layers of gills. Now over to you. Can you comment on this as gaseous exchange surfaces? Those are the gills. Mm-hmm. These projections, all right? Mm-hmm. Gill filaments. Mm-hmm. They are multi-layered also to do what? To increase surface area. Mm-hmm. Anything else? Mm-hmm. They have a gill bar for attachment of. Mm-hmm. How come they are red? They look like. Yes. Now, people from this side, you're not talking. Eh? Javan and Sarah, I need to hear from you. Please give us. Now, are these thick or thin?
Thin.
Why are they thin? For? Yes, to reduce the distance for diffusion of gases. So the shorter the distance, the faster the diffusion. Great. Now, are they dry or moist?
Moist.
Why are they moist? Because? Yes. For easy diffusion of respiratory gases. So the respiratory gases dissolve within this moisture that is in there. Okay. Yes. Hey, you will pay me for touching these things. Now there we go. And they are so delicate, by the way. They are thin-walled. Or rather, not walled, but they have thin membranes. Okay? So basically that is it. There is one here that is really nice. Oh my, can't see. You see? So you can imagine they have numerous capillaries to allow oxygen to be absorbed and carbon dioxide to be released out. Kwa hayo mengi na machache. Yes. Thank you. They have a gill rack that acts as a sieve. Are we together? Because the fish is swimming in water, and water has many particles that should not come to the sensitive gills. Are we together? Yeah, so the gill rack acts as a sieve to sieve off any unwanted particles from accessing the gills. Okay? What? Which waste product? Which waste product? You have an anus. Here. Is it that you have never looked at a fish nicely? You just eat. Hey, the one who slaughtered this one. Okay, yeah, they have removed the They have removed the intestines, yeah. But I don't know why it looks like this still. Hey, can we move to something else, please?
40 hours.
Oh, wow. Wow. Hey, Alvin, you're ambitious now. Wow. Was there any other specimen that we were supposed to review? Not right now. Not right now. Yes, just the fridge. Yeah, we can throw away. I don't think we will review them again. Okay, let's continue. Let's go on. Where are we in the workbook? Okay, let's go to the contact process. Can we discuss the contact process quickly? Now the contact process, guys. Let's focus. Please give me a few. I open my notes. Okay, now we are looking at how we make sulfuric acid by the contact process. Now, what are the raw materials for contact process? We have sulfur, air, and water. Are we together?
Yes.
Can we all pay attention? We are looking at the contact process, and I'm discussing the raw materials for the process. Now, the contact process is an industrial process through which we make sulfuric acid, okay? Now, the raw materials are sulfur, air, and water, or sulfur dioxide, air, and water. Now, when we start with sulfur, the first thing we do is that we burn sulfur in air. So I want you to write the balanced symbol equation for combustion of sulfur, starting with solid sulfur plus gaseous oxygen to give you sulfur dioxide. That's the step number 1. Step number 1 is combustion of sulfur to give us sulfur dioxide. Oh, I wish you had saved space. How will it fit? All the things I want to tell you. Okay. I want to see that reaction. Okay, so it's S plus O2. Remember, oxygen is diatomic. Oxygen is diatomic. So it's S plus O2 arrow to give you SO2. then insert state symbols. It's already balanced. It's already balanced, okay? So that is step number 1. And then step number 2 is mixing that sulfur dioxide with more air. Are we together? Step number 2 is mixing the sulfur dioxide with more air. And then step number 3 is passing that mixture, passing the mixture through a catalyst of vanadium 5 oxide. Vanadium 5 oxide. How do you write vanadium 5 oxide? Has the other group come back? Okay, group 3, please go for your rest. Group 4. Thank you. Please, when we are going out, we move quickly so that the class continues. Now, the other condition that should be provided for this reaction to take place is 450 degrees Celsius of temperature. Temperature of 450 degrees Celsius. Okay, so that is step number 3. Now, as a result of step number 3, we move from sulfur dioxide to a reversible reaction of addition of oxygen to give us what? Sulfur trioxide. You want to come in? Bilha, you want to come in? Now let's write a balanced reversible reaction for conversion of sulfur, or rather oxidation of sulfur dioxide to sulfur trioxide. Tri means what? 3. Are we together? Yes, so sulfur trioxide all these are gases we are dealing with. Now, can you balance this equation and tell me the mole ratio for the 3? Balance the equation. Can you balance the equation, please? Give me the mole ratio. Sorry? Hey. Sorry? 2, 1, 2. So it's 2, 1, 2. It's balanced, eh? Okay. So that's formation of what? Sulfur trioxide in the presence of a catalyst, vanadium 5 oxide. It's not working. Okay. So that is step number 3. Now step number 4 is dissolving the trioxide, the sulfur trioxide in concentrated sulfuric acid to give us oleum. Are we together? So we have and then now the oleum is mixed carefully with water to give us concentrated sulfuric acid. So the oleum is carefully mixed with water to give us concentrated sulfuric acid. So I've already talked about the raw materials. I've talked about the things to note about the contact process. Now, uses of sulfuric acid. Can I give you the uses of sulfuric acid? But you can give me what you have first, and then if there is need for more, we will add. Yes, Clarice. Used as a? Used in making sulfate fertilizers. Used in making sulfate fertilizers. Used in making sulfate fertilizers. Another one is that it's used in making paints, pigments, and dye stuffs. Used in making paints, pigments, and dye stuffs. Paints, pigments, and dye stuffs. I think that socket has a problem. Okay, the third one is it is used in making fibers and plastics. Used in making fibers and plastics. Used in soaps and detergents. Used in soaps and detergents. And lastly, sulfuric acid is the acid that is used in car batteries. Now I want us to go to 1.74. And in 1.74 we are looking at acids, bases, and salts. Now before I even bring for you the inorganic acids and alkalis that we have in the lab, plus the pH papers and everything, when you hear the name acid, what comes to your mind? Mm-hmm. Yes, Aaron? Bana. You know, you're just a scientist. I just wanted, like, what comes to your mind when you hear acid? You want to tell me when I say acid, you start thinking about the concentration of hydrogen ions? Huh? Fabian?
I think it's corrosive.
Sorry?
Corrosive.
Corrosive, yeah. So when you hear acid, you don't even want to touch it because it's corrosive. Would you want to drink it? Harmful to health if ingested or if it spills on your skin. Now, if you have had a problem with hyperacidity, who has ever had a problem with hyperacidity, like too much hydrochloric acid in the stomach? None of you. You should pray that you never get it. You have ever experienced that? Yeah, so for me, when I hear acid, as much as I'm a chemistry teacher, the first thing I remember is hyperacidity, and I'm like, hey, okay? Now, when you hear bases or alkalis, what comes to your mind? What comes to your mind when you hear bases or alkalis? Yes? Oh, so when you hear bases, you think of pH immediately? No. We start tuanze kwa ground. Eh? Yes?
Alkaline substances.
Sorry?
They are alkaline substances with hydroxyl group.
Mm-hmm. Well, that's okay. Mm-hmm. What else? They are harmless. Well, I didn't know. Sorry? Now, for me, just thinking about acids from home, acids are sour in taste. Are we together? Acids are sour in taste. Now, acids can corrode the skin, can corrode clothes, and any surface that they fall onto, okay? Any surface that they fall onto, they can corrode. Corroding means they are able to react with that surface and, eat away that surface, all right? Now, I know that we have important acids like vinegar that we use in the kitchen. Vinegar is weak ethanoic acid. Are we together? Yeah, so before I even allow us to interact with the acids that we have here in the lab, I want us to think about substances that could be acidic in our environment and list them down. Also think about substances that could be having alkalis, or could be bases in our environment. And then lastly, I want us to think and come up with substances in our environment that are salts. I know sodium chloride will be there. Okay, 2 minutes for that. Marlene, I need the pH papers. Litmus. Mm-hmm.
Orange. This is the color.
Okay.
Which other salts?
This is blue, red. Mm-hmm.
So you know what to prepare.
pH paper.
pH paper we don't have. That one we don't have. But we have universal.
So you just dilute this, Anna. There's a specification.
I'm not sure if it dissolves in water. Let me check how dilute
Okay.
it.
All right. So then test tube rack with
tube rack.
I'm coming with some substances that could be acidic. We are going to investigate their behavior.
Okay. Go and take electrolytes. Excuse me. Excuse me. One of my students needs this. She's feeling how I was feeling yesterday. And she has been feeling like that since 4 a.m. This will sort you out, eh? Okay, they are bringing for you.
Okay, I want us to investigate a few substances. Well, it doesn't matter what substance it is. Are we together? Yes. We are just investigating to see whether it is acidic or not. Now, how do we investigate substances, or how do we test to see whether a substance is acidic or not? What do we use? We use indicators. Are we together? So we have pre-prepared indicators, and we can prepare indicators using the things that we have around us. Okay? Like red cabbage. When you crush red cabbage, add some water, allow it to soak, and then filter. Whatever you obtain is an indicator. An indicator is any substance that changes color in the presence of an acid and gives a different color in the presence of an alkali. Okay? Yeah, so I have the universal indicator here. Now, the advantage of this universal indicator is that it will give me a specific color. It will give me a specific color that will tell me the pH. Okay, so the pH will actually tell me how acidic is this substance, how alkaline is it, etc. Okay? So, I want us to test around 5 substances. Around 5 substances. Now, it will not make sense or it's not any lesson for me to bring for you sulfuric acid here and ask you to test for it, isn't it? It is more exciting when I bring something like soda and I ask you to test to see whether it is acidic or not. You want to drink it. See you. I know my students. Now, this is also an indicator called the penophthalane indicator. Now, my students who are on this side, I'm sorry for showing you my back, but when I'm doing a demonstration, you can come here, okay? Actually, let me do it from here. So we have different indicators. We have penophthalane, we have red litmus paper, blue litmus paper. We have the universal indicator. And then I think she's preparing for me methyl orange as well. Now, where is my test tube rack? Thank you. And then I'll need some droppers. So the first thing we will test is this ORS. I told you that we just investigate anything. As long as at the end of the day we have come out of there with a scientific skill and scientific knowledge. Okay? So this is ORS. ORS is a constitution, okay, of salts and sugars. Are we together? That when someone is dehydrated or someone is weak, you know, in terms of less salts and sugars in the body, they give it to you. It's like medication, actually. Are we together? Yeah, to replace whatever you have lost. Okay? Please cover it for me. So I'll just put so hold that. It's harmless. Very, very harmless. Extremely harmless. I've been drinking it. Yes. Where did I get it from? And then, how many indicators do I have? Thank you, my dear. 1, 2, 3, 4 for now. So 1, 2, 3, 4. You want 1? Can someone be writing for us the observations, okay? So we'll use all the 4, we are going to use all the 4 indicators, okay?
Yes.
Fabian, you're the one who is writing the observations. Now for her, I will put a few drops of phenolphthalein and see how it behaves. Which color? Just a few drops are enough. Make sure I don't use this on another one. Yes. Okay, so just hold that. You can shake. All right. For my portion, I'm going to use red litmus paper. So is there any tangible change here? None? Okay. There's a slight color change. Can we contrast? So the msema kweli is this one, the one that will even tell us the pH. Okay, it's okay, I can even do this. All right. There it goes. Then I'll give Miss Damaris a blue litmus paper. So this is just substance 1 that we are testing, substance A. Just to see the behavior of different substances in indicators and so you'll do what I've done. You'll insert it, shake, and then you see. And then for you, I'll put a few drops of universal indicator. I can't hold this without gloves. Get me one. From blue to? And have you noticed that yours is going to colorless? Or am I seeing wrong?
Yeah, very.
Mm.
That is why
Why are you touching a bottle that has reagents with your bare hands? Don't you? Who does that? Hmm? Don't you care for your life? Okay. Hey. Okay, so where is yours? So this is using phenolphthalein. This is using red litmus paper. This is using blue litmus paper and universal indicator. Now for the universal indicator, Javan, you just try and contrast it with the color, okay? Now which? The first one, it matches with the first one. Don't know if you can see. So it has a pH of 4. So it is. I've been drinking an acid. It's acidic. Can you imagine? I've been drinking an acid. I'm surprised. It matches exactly with pH 4. Okay? So can we sit and write our findings with the 4? For that particular one. So the solution we are studying is the ORS solution. The medical ORS solution. Do you have... Okay, come we test with methyl orange. Come we test with methyl orange. So just a little of that was the extra. My throat is now sensing that something is happening. So this methyl orange is also, so we are going to write the colors we have observed in all. And no wonder it didn't no wonder it didn't change when we put the red litmus paper, isn't it? Yeah. This thing is acidic. I'm going to put a few drops. No change. Hey. Huh? Yeah. You know this turns red in an acid. Base methyl orange turns red in an acid. Hey, Ayimba. Pana. So let's write our findings. I don't think we are going to investigate another one unless need arises. Now please come for the data from Omala. Pick data from Omala. We were investigating the medical ORS. We were investigating whether it is acidic or alkaline using various indicators. Copy that quickly. Can we take another 2 minutes, please? So you write the color. It was trying to be colorless because it normally turns colorless in acid. Yeah. And it turns purple in alkali.
The blue changes to red. Universal indicator was this color, pH 4.0, according to science.
Now, for purposes of the activity we are supposed to do in the next page, I am making a soap solution. Are we together?
Yes.
I'm making a soap solution, and then I will distribute this to you. Okay? You're going to use in groups. You're going to use the different indicators to try and assess whether this is acidic or alkaline. Okay, no, we are not going to use several indicators. We are going to use the universal indicator because it's the one that will give us the exact pH. How many groups are we? 4. Fourth group. Now, what are you looking for? Yeah, actually that's the dropper for the universal indicator.
in class?
No group exercise.
You can't go when we are less than 15. Are you sure? Okay. Can you investigate the solution, the soap solution I've given you? You want to rinse that? Now put about 5 drops. 5 drops of. It's okay, Bilha. It happens. Now, Bilha, go and place it where I normally place mine. When you need to sit, you go sit and come, okay? 5 drops. Now use the bottle for pH, okay? Use the bottle for pH, the universal indicator, sorry, to get the actual pH of that solution. And now tell me whether the solution is acidic, alkaline, and what pH it is. So that activity is for the next page, where we are talking about the pH scale. Use different solutions, identify them based on universal indicator. Distinguish. Okay, what pH is the soap solution? 5. Wow. That's interesting. Now, do you think the original color of the soap would have influenced the final color? So that is a source of error. Because you can only say that that is the actual color if the soap was a transparent soap. Are we together? Yes. So as you are writing your findings, it's also always important to indicate the source of error. So you're writing that under that pH, under the pH meter that has been printed for you there. So you're mentioning the substance and what you have done, your findings, and the source of error. Wait.
So you can go now. How long are you going for? Okay. Let him be. Mark, come. So now, these are the investigations I want to do today. So this one, they say that they are going to make another delivery tube. Okay? Okaka said he will make, I don't know if it's Okaka or, yeah, he said he will make this. And then this one is a pending activity between the students and I. I've already done that. This I'll do later. Now, this is what I want to do. I'm not sure what time it is now. 9:37. This is what I want to do when I come from break. I want to react an acid with excess carbonate, filter, evaporate, crystallize. Alright. I also want to react a metal, excess metal in acid. You can choose to do excess magnesium, but magnesium is the best, yeah? Still, this can replace this depending on whether they'll make for me, okay? Then I want to do displacement reactions, so check the reagents that are available and plan, and then precipitation reactions, where I'll be mixing 2 soluble salts. So these ones I can do like 3. We'll just be making solutions, we react them, we write the simple equations. So check the reagents that are there. You can see salts, they also have salts, and then you see. So my break is at 10 to 10:30. So when I come back at 10:30, I want to investigate this. Yeah, let's start with this, and then this, and then by the time we get here, we'll see. So. Okay, now you have written the wrong place, because this was here, right? Because now I want us to describe the main reactions of acids with metals, bases, alkalis, with carbonates, and do simple practical sessions on each of these. Write word and chemical equations. So for now, before I go for my break, I want us to describe the main reactions of acids. The main ones are acids with metals, acids with bases, and alkalis. By the way, what's the difference between bases and alkalis? Or we just say, huh? They are not the same. Bases are insoluble metal oxides. Yes. Bases are insoluble metal oxides, like copper oxide. That's a base. Okay? And then alkalis are soluble metal oxides, like sodium hydroxide, magnesium hydroxide. You should thank me later, man. Huh? That's why you're finding me a bit uncomfortable just saying bases. I'm saying bases or alkalis, because those are two different substances, okay? Yeah. Okay, so the first, so we are back to 1.74, the second objective, where we are supposed to describe the main reactions of acids with metals. Now, give me an acid, any inorganic acid. Yes? You're finding it hard to get an inorganic acid? Nitric acid. reacting with, so this is acid plus metal to give you salt plus hydrogen, okay? So we have nitric acid plus zinc to give you zinc nitrate plus hydrogen. Are you together? So what is the formula for nitric acid? Plus. So this is in aqueous form. Salt, and so we have neutralized it. So we need to wrap the narrative that a neutralization reaction is just for acids and alkalis or acids and bases. Are we together? Yeah. Today your facts are changing, yes? Sorry, displacement reactions. Now, displacement reactions do not have water as a product. That's number one. A displacement reaction will have a metal, okay, and a salt as products. Now, if it is a double displacement reaction, it will have two salts as reactants and two salts as products. Are you together? Yeah. So, I had said I'm going to use hydrochloric acid and Or let's use sulfuric acid. Sulfuric acid and copper oxide, okay, to give you copper sulfate plus water. So what do I call this also? It's also a neutralization reaction, isn't it? Now let's write a balanced chemical equation for this. What is the formula for dilute sulfuric acid? Yes? Mm-hmm. What's the state symbol? Hey. Where? What is the state symbol? Aqueous. Plus copper oxide. Formula for copper oxide? Solid. To give us copper sulfate, everybody's favorite salt. Okay? Because it's blue and it turns white when you heat it. And what? Water. Is this equation balanced?
Yes.
Yeah, it's balanced. So this is reaction 1, this is reaction 2. Now, reaction 3. Reaction 3 is between an acid and an alkali. Now, I'm not going to do one for an acid and a carbonate because we just did an investigation on that one. You remember? We did calcium carbonate and sulfuric acid. So we are going to look at which acid haven't we used here? Hydrochloric acid, just the common one, and magnesium hydroxide. Let's do that one. So acids plus alkalis give us salt and water. Again, this is a neutralization reaction. So we have hydrochloric acid plus magnesium hydroxide to give us, somebody tell me the salt we'll get here. Maitha? Okay. Magnesium chloride plus water. Okay. So we have that in aqueous state plus magnesium hydroxide in aqueous state as well. Aqueous means what? What does aqueous mean, Lenny? What does aqueous mean? Oh my. Yes. Which solvent? Which solvent? Water. Tulisema no overthinking. Are we together? Yes. Lenny, did you know that aqueous means dissolved in water? Dissolved in water. You knew. But when I asked the question, you imagined the question is harder than it sounds. Huh? And immediately you didn't know the answer. Unajishuku. Anyway, so we have magnesium chloride plus water. So this is in liquid and this is in aqueous form. Can we balance this equation, or is it balanced already? It is not balanced. I'm already seeing where I should put a 2, but I don't want to tell you. Diana, go and balance that equation. The way you are peeping. Go and balance it. The battery is on. Where are we now? Oh, we were balancing the equation.
It's not.
Now why are we arguing? Can we just count the atoms? How many hydrogen atoms are there? 4. 4 on the left, 4 on the right. 2 chlorides, 2 chlorides. 1 magnesium, 1 magnesium. Then 2 oxygens on each side. Okay, we are done with that. We are done with that objective. So we are moving on very, very well. Now I want us to discuss the pH scale and the pH chart. You said I came back at 4:1. I came back at 4:1. Now, the pH scale is a number line of acidity, neutral substances, and alkalinity. Are we together? Now, it's very clearly described there. At 7, we have neutral, and the lower we go, the more acidity the substance becomes. So if I am comparing two substances, one with a pH of 1 and another one with a pH of 4, the one with a pH of 1 has a higher power of hydrogen. I said pH means what? Power of hydrogen. All right. And the higher you go, the more alkaline or basic a substance becomes. Now we have the pH chart, and we use the pH chart together with the pH scale. So like for example, you saw me comparing the colors for the ORS after we put some universal indicator. and I was trying to match, and the exact color gives you the exact pH. And that is the advantage of the universal indicator compared to such indicators like phenolphthalein. Phenolphthalein will only tell you whether it is acidic or alkaline or basic. This is methyl orange. It will just tell you the same, like it will give you limited information. And these litmus papers as well give you limited information. So the best and the most accurate indicator is the universal indicator. We work with the universal indicator, the pH chart, and the pH scale. Are we together? Yes. So continue describing your investigations for soap. I'm seeing some people have not finished. On the space beneath the pH chart, that is where you are describing the investigation for soaps. Any other pending work, you do it now. What time do you want to do the exam tomorrow? I think 2 hours. Yeah. A science exam. You don't want to do an exam? I may not help you. It's one of the requirements, but a lesson is complete after assessment is done. Yeah. Sorry? He's asking me if I will grade. Of course. No, it will be a random assessment test of the things we have been doing since Tuesday, okay? Today is Thursday, imagine. Unbelievable, huh? Okay, can we complete the work? Now, can I mention something about strong acids and weak acids versus concentrated and dilute acids? Can I mention something about that? How many minutes do I have? I have 2 minutes. Okay, in those 2 minutes, I can talk about strong and weak acids. Now, when you hear a strong acid and a weak acid, what comes to your mind? I just want to hear from you. What comes? Yes? The pH value. Mm-hmm. The uses. Uh-huh. Strong acid and weak acid. Yes? The concentration. What about concentrated and dilute? Okay? Yeah, so that's a very good question I have there. Yes, Cynthia? Stop giving us the answer. Wait, please. I just asked, when you hear about weak and strong acid, I'll give you an opportunity to give us the answer, okay? Just hold it a bit. I want to hear their views about strong acids and weak acids. Clarice? You have examples? Uh-huh.
Strong acids,
Uh-huh.
HCl,
Uh-huh. Uh-huh.
weak acids,
Uh-huh.
vitamin acid.
All your examples are right. Okay? All your examples are right. So, Cynthia, tell us what a weak acid is and a strong acid is.
A strong acid is a substance that dissociates fully in water, producing hydrogen ions, while weak acid is a substance that partially dissociates in water to produce hydrogen ions.
Okay, you'll repeat that when I come back.
There are different staff within solutions for chamas, where we can be able to open up different opportunities for them to be able to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for them to be able to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for them to be able to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for them to be able to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for them to be able to save and invest as solutions for chamas, enjoy where we can be able to open up different how to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for how to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for how to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for how to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for how to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for how to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for how to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for how to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for how to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for how to save and invest as solutions for chamas, enjoy where we can be able to open up different opportunities for how to save and invest as solutions for
and join countless satisfied clients who have made the smart choice for their protection needs. And join countless satisfied
In
clients
an uncertain
who have
world,
made the smart choice
trust
for
is
their
everything.
protection needs.
Introducing
And join
Tamka
countless
Security
satisfied
Services
clients
Limited.
who have
Your
made
trusted
the
back
smart
trust in
choice for their
security
protection
solutions.
needs.
Introducing Tamka Security Services Limited. We understand that security is not just about protection. Services Limited. That's why we
CPF is a financial services company that offers a whole host of solutions to the Kenyan public and across the globe. We have been recognized both locally and internationally as a trusted brand, and the following are some of the reasons why you should be working with us. Currently, we provide fund administration services to the largest schemes in the country. One of them is Lab Trust, which is the oldest. Having been established in 1929, it currently has a fund value of 30 billion Kenya shillings and membership of about 20,000 members. The County Pension Fund, which is also one of the largest in the county space, and the Public Service Superannuation Scheme. Overall, we have total assets under management of 100 billion. One of the biggest challenges in the social security sector has always been enabling people save towards their retirement. And one of the solutions that we have developed internally at CPF is called Rukisha. Rukisha is a concept that we developed primarily to address people in the informal sector, people with small businesses, people with big businesses as well. And the intention is to help them save towards their retirement. We have incorporated a concept called Save As You Spend into the platform, where for every transaction you make, you're able to save a percentage of it, and over time you're able to see your retirement funds accrue. One of the other benefits of utilizing Rukisha is you also have access to other solutions within the CPF group of products, among them being investments through the CPF asset managers. You should be able to save insurance products under the Laser Insurance Brokerage Services, as well as the real estate products within the Laser Property Management Services. For more information on Rukisha, visit www.rukisha.com. You can also access it through the shortcode *391# or download it in the Google Play Store as the Rukisha app. Talk to us, reach out to us, and we shall help you achieve your retirement goals. You can also access it through the shortcode *391# or download it in the as a Rukisha app. Talk to us, reach out to us, we shall help you achieve your retirement goals.
At CPF Financial Services, we've been able to package the solution for both for the individual, for the corporate, and also for groups. At the individual level, we've come up with products that are able to take care of the member both at before retirement and after retirement. Before retirement, we have training for the member to be able to prepare themselves to go out there and be able to save for themselves. Also at that particular level, they can be able to save individually on a continuous basis with as low as 50 shillings every day or 500 per month to be able to take care of themselves at the point of retirement. At corporate levels, we have solutions where we carry out fund administration for corporates that have able to join our umbrella DC schemes within this. Also do gratuity staff within the organization. We also have schemes, solutions for chamas, where we can be also do gratuity opportunities for them to be able to enjoy welfare within the organization. We also have solutions for chamas, where we can enjoy welfare within the organization for you to do governance audit, strategy development, among other consulting services that you might request. We also do trainings, and at trainings we have trainings that are bespoke to the organization, or they can already be able to come in at best prices to attend some of the trainings that have already been packaged by the CPF arm. For more information, visit our website on www.cpf.or.ke, or you can be able to access the information on the CPF app on the Play Store or the iOS Store.
Prayo bwana, asante kutupeleka holiday bwana. Lakini na swali, uliniambia tunasave na CPF. Kwani ukisave unapata pesa wapi?
Boni, unajua first una save, halafu una spend. Nilikuwa nishaweka kitu CPF kabla sherehe.
Oh, okay. Na kama sina kitu this month nafanyaje?
Usistress. Ukiwa na CPF, unaweza convert Safaricom Bonga Points zinakuwa contribution yako kwa M-Pension. Na ni rahisi sana. Dial *289# au piga 0111 114 000 na CPF watakusort.
Hello, my name is Faith Wanjiru Kinyanjui. I'm a 4th year student here at Jomo Kenyatta University of Agriculture and Technology. I'm pursuing a degree in horticulture, and this is my final semester. So I lost my dad in 2018 when I was in first year, second semester, and it was a 1 week illness. After his death, my life was kind of difficult because I didn't know if I was going to continue with my studies because my mom is a housewife. And so when I joined second year, my first semester, my mom introduced me to Lab Trust after she received some phone calls from my dad's workplace. And so we went with her because I'm usually here in Nairobi. So when we went, they assured me that they were going to pay my school fees and I didn't have to worry. So that was like a saving grace for me. And since then, my school fees has always been paid. My upkeep is always in check and my house is always in check. I've never lacked anything since then in second year, and up to now I'm in my fourth year, final semester. And as you can see, due to Lab Trust, I'm able to carry on my project. Here is one of them, and I'm studying my plant diseases, and I'm using a treatment known as silicone. As you can see, then I'm controlling the disease. Due to Lab Trust, I'm able to carry on my project. Here is one of them, and I'm studying my passion, the plant diseases, and right now I'm in my final semester, and then I'm controlling the disease. Due to Lab Trust, I'm able to carry on my project. Here is one of them, and I'm studying my passion. I can join the skills. Feeling our lives. I have two sisters at the moment, one in college and the other one is in grade 4 in primary school, and they have been paying for their fees as well, and we can say our life has never been the same, and we are so happy for CPF and how they have helped us.
In an uncertain world, trust is everything. Introducing Tamka Security Services Limited, your trusted partner in security solutions. At Tamka Security Services Limited, we understand that security is not just about protection, it's about peace of mind. That's why We specialize in providing comprehensive security solutions for homes, residential areas, and malls. Our team of highly trained security guards equipped with state-of-the-art technology ensure round-the-clock surveillance and protection. From guard services to K9 units, from installing electrical fences to providing quick response in times of emergencies, we also offer bodyguards and event security. Tamka Security Services Limited is your one-stop solution for all your security needs. With our commitment to excellence and swift action, you can rest assured that your safety is our top priority. Choose Tamka Security Services Limited for security you can trust. We are located at Rimpa along Magadi Road, and you can contact us on 0202 595098. Tamka Security Services Limited, protecting what matters the most.
His Excellency Mike Mbuvi Sonko, the Good Deeds Ambassador, crowned for his generosity in helping the needy. Sonko's move to help the needy is his way of life and started way before he joined politics. Hundreds of needy people from all walks of life can attest to this. Mariam Abdallah has been in and out of hospital, but Governor Sonko has always been there for the family.
Namshukuru sana mheshimiwa, yeye na familia yake, na nawaombea sana kila nikiswali Mwenyezi Mungu awajalie kila la kheri.
Sonko kwanza, Mwenyezi Mungu amjaze kila la heri, amuondoshe matatizo yake, mazito amfanye mepesi, familia yake.
Up there, reaction of hydrochloric acid with magnesium for testing rates of reaction. Can you open where it is? You remember it? The one we tried connecting and it refused. It is after 1.70. Now we are testing the concentration of, we are testing the effect of changing concentrations on
So we are looking at the rate at which hydrogen gas is made when magnesium reacts with two different solutions of dilute hydrochloric acids, C and D, with different concentrations. The dilute hydrochloric acid is in excess both experiments. Are we all there? After 1.70, now ignore the confidential instructions, the CI, go to the procedure in question, the next page. Are we all where the procedure? Hey, sweetheart, you're lost? Let me find you. There you go. So we are investigating the rate at which hydrogen gas is made when magnesium reacts with two different solutions of hydrochloric acid, C and D. Now, we are going to demonstrate it for you here. So we had requested that you come with your handout here so that you can collect the data as we do the demonstration. Are we together? Yes. Are there other rubber gloves? These have been used and returned. Oh.
Itabidi nikushikie hiyo kwa sababu itavunjika.
Sorry? Can you open where the procedure is?
1.7.
Just relax in kwa hiyo page.
Oh, need.
Yeah.
Oh, ningo better at that.
It's a 50 centimeters cubed of dilute hydrochloric acid into a conical flask. Okay. Okay. Now, are we all at the procedure? There's a stopwatch there. Okay, now use a measuring cylinder to pour 50 centimeters cubed of dilute hydrochloric acid in into a conical flask. Where is C? Where is C? Which one is C? Where is C?
We have 0.5 and
Okay.
0.7 and 1 more.
So 0.7 is C is one molar. Where is it? So we are measuring 50. We don't have smaller ninis for 50. That's 50, right? So and then use a thermometer to measure the initial temperature of the dilute hydrochloric acid. Now I'm seeing it's around 24. Are you together? Are you recording? Initial temperature is 24. Set the apparatus up as shown in the diagram, ensuring the inverted measuring cylinder is full of water. So we are going to set the apparatus . Okay. So so where is the magnesium?
It's here. It's here. Right.
Okay. Now we are measuring the volume recorded after every 20 seconds.
Yeah.
Are you the one measuring?
Are you?
So will you look there and look here? Huh? So you'll say when it's 20 seconds. Okay.
Once it's busy, you tell us when it's 20.
20.
20. 40.
40.
14.
$60.
55.
80.
65.
100.
70.
120.
95.
140.
115.
160.
120.
Okay, so final temperature. I want to take the final temperature. That's 38, okay? 38. So initial temperature, we use the same.
Yeah.
Same. Okay, are you recording the data?
Yes.
Si mnaona ni vitu rahisi rahisi tu. Go to the next page of this. Initial temperature, use the same. Okay? Kujua kwanza nipime nini? HCl ama mshapima? Oh. Dulu. What can you already tell from that data? What can you tell from that data? Yes? You have to, yeah? Lucy, what can you tell? Good. Volume of gas increases as time increases. And then what have you discovered concerning the temperature? The reaction is? Okay. Where is D? Where is D? Let me measure the HCl first. .7. Where is 0.7? Okay. Hauogopi acid? So we are not measuring the initial temperature again because we are using good, good.
Your time now? That is around 0.4. Not 0.4, sorry, 4 centimeter cubed. Centimeter cube. So it was 14, then 17. I'm sorry.
60.
20.
kg.
30.
100.
40.
120.
50.
It's okay.
$140.
60.
Mm-hmm.
And 160.
70.
Mm-hmm. So we have all the data. Yeah? Mm-hmm. Yeah. So basi, you let me confine it. Are you ready for a bomb? I told you. Please come again. Hmm?
I was not ready for that.
What is that? Yesterday you were playing with it. You were not popping. Hmm? Mm. Allah?
Is it?
It's
okay.
It is. Splint. So, what next? Complete a suitable scale on the y-axis and plot your results from experiments 1 and 2 on the grid. Draw two smooth line graphs. The lines must pass 0, 0. Clearly label your lines. So what are you going to label your y-axis? What are you going to label your y-axis? Now time is normally in the x. Imeenda. Go back to your seats. We do the question. Group one, please. It's your time for your health break. Are you okay? You look very happy. Is everything okay? You're not tired? You're not tired?
I am not really sure that this project is successful.
Amen.
Even if I get so tired, I will try my best.
Okay, please let's draw the graph and let's not take a lot of time. Oh, final temperature for the last one. Ooh, has it been disposed? Has it been disposed? The final temperature. Oh no. Final temperature for the other one, you have already disposed it? Okay. Disposed. Yeah. We are giving you graph paper. Now there are some glue sticks you can use to stick the graph paper. Actually, stick the graph paper on top of that one. Are we together? Yeah, I think it's better if you use the one that... Less than 24 hours to go. Haron, it is easier to use this. That one is too dark. So I had, okay, there's a glue stick there. There's another one here. Now, let's do this together systematically. Are we together? What you can do before sticking, you can work, and then when you have the final graph, you stick the graph, all right? Yes? Yes, so we are drawing one graph with two line graphs, okay? Because we are comparing their reactivity based on concentration. Now, can we write the suitable scale on the y-axis? Now, the suitable scale in this case is volume of gas collected in centimeters cubed. Volume of gas collected in centimeters cubed. Volume of gas collected in centimeters cubed. Then the x-axis is time. The x-axis is time. Now the starting point for that graph is 0, 0. Now, can we decide on a scale for the x-axis? Yes? $20 per every big square? That is for y. Okay, what is the range of values for volume? The lowest is? The highest is? 120. So we can do 10 per 2 squares, 10, 20, 30, 40, 50, 60, 90, okay. 10, 20, 30, 40, 50, 60, 70. Okay. For every square of 5, you award how many units? 10. Yeah. Thank you. So that will make sure that your graph has occupied at least half that page. Now please plot for C. You draw. Now the instruction is that all the line graphs must start at 0, 0. So I'm just giving you a few minutes to plot. Please use portrait, not landscape. Portrait orientation, yes. Yes. Can I see clearly labeled line graphs? Please don't take so long plotting so that we can go to the questions. Now, after drawing the graphs, the line graphs, you can obtain or deduce the volume of gas that was collected after 50 seconds in experiment 2. So you just come to 50 seconds and draw a vertical line, all right? A vertical line going up to where it touches the experiment 2 curve, and then draw a horizontal line towards the y-axis. We set for reaction of acid with excess carbonate. Huu kijana tunaona ni mkono unaweza fanya naye kazi. Ndio. Nikitaka. He's my volunteer.
Very resilient.
Very. Watu wakitoka haonyeshani kuchoka. Sawa. Ni hii reaction of acid with excess carbonate. I'd like to filter, evaporate, crystallize. Not even me, we can give them in groups 1, 2, 3. Actually, just 4 stations. Yes. Who has completed the curves? Sorry? So the last instruction is you answer question D. From your graph, deduce the volume of gas that was collected after 50 seconds in experiment 2. Okay? Yeah. So show clearly on the grid. So you'll come to 50 seconds, draw a line going up. Then where it touches experiment 2, yes. So experiment 2 was for D. Yeah. Yes. So can you deduce the volume of gas collected at 50 seconds for experiment 2? 50 seconds, okay. So draw a vertical line, and then where it touches experiment 2, you draw a horizontal line touching the y-axis, and then write the volume. You're doing well, guys. Clap for yourselves. I'm so impressed. Huh? You're doing very well. Can we deduce the volume for the volume at 50 seconds? Sorry?
For experiment 2 or both?
No, they are just asking for experiment 2. Now, because we were not able to collect the final temperature for experiment 2, now the way you have seen those two concentrations behaving, can you predict the final temperature for experiment 2? Predict, let me see your predictions. 32, yeah. As long as it is lower than the experiment 1 and it is higher than the initial. Are we together? Yes. So we are going to undertake another reaction of acid with excess carbonate, but the aim of this reaction is to obtain a pure salt. So we are actually obtaining a pure salt by reacting excess carbonate. Why should we use excess carbonate? Why should we use excess carbonate here, Sarah? Yes, to ensure that the reaction is complete and that all the acid has been used up. Okay? Now, have we all answered question D? Now, let's go to E. We are doing this together. Okay, finish drawing the graph, stick it in the workbook, and then we go to okay, let's go to E. Let's go to E. Now we are explaining we are explaining what can be deduced about the concentrations of dilute hydrochloric acid C and dilute hydrochloric acid D. Now I want to hear your views on this one because they could be different. What do you deduce about the concentrations of C and D? I want to hear other people's voices. Imelda, excuse, how are you? I want to hear your voice. Martin, have I heard your voice today? You sure? What do you think about the concentration of the two acids? Wait, if you're wearing a sweater, who is this? Javan. You will boil in this lab. Hmm? Martin, what do you think about the concentrations of these two acids, C and D? Yeah, higher. Yes. The concentration of C is higher than D. And this is because the reaction is faster. The reaction is faster and more gas is collected within the same time as D. So they were both given the same time, but C ended up giving us a higher yield of hydrogen gas. C gave us a higher yield of hydrogen gas, and that makes it more reactive than D. Now, are we filling in the answers as we proceed? Now, what happens to the temperature of the dilute hydrochloric acid during experiment 1? What happens to the temperature of dilute hydrochloric acid during experiment 1? Damaris, have I heard your voice today? Did you feel better? You drank all of it? Oh. Yes, Dama? I want you to answer question F1. The question is asking, what happens to the temperature of the dilute hydrochloric acid during experiment 1? So you're comparing initial temperature and the final temperature, and then you tell us what happened. Yeah, so in science, we give the exact number. Are we together? Yeah, so you say that the initial temperature was 24, and the final temperature was 38, so it rose by 14 degrees Celsius. That is now a good science answer that has facts and data. Okay? Now, what effect does this temperature change? Okay, state what effect this temperature change has on the total volume of gas when the reaction has finished. What effect does this temperature change have on the total volume of gas when the reaction has finished? What happens? F2. Now, does any stay the same? Yes? Yeah, so you just say none stays the same. What effect this temperature change has on the total volume of gas when the reaction has finished? It has nothing. It has no effect. So the reason why we were measuring the temperature before and after has nothing to do with the concentration and the volume collected. So it does not have any effect on, the temperature has no effect on the volume of gas collected. Now, what change can be made to the apparatus or reagents to reduce the temperature change of the acid in experiment 1? A change that can be made to the apparatus or reagents to reduce the temperature change of the acid in experiment 1. Now, looking at how you are seeing us doing that experiment, changes would you have made if you were the one redesigning that experiment? Yes? You would? You would? So you would like put a thermal coat to prevent loss of heat from the system, yeah? That's interesting. What about using a gas syringe to collect the gas instead of inverting the measuring cylinder? Isn't it? Yeah. And then also measuring the volume of? Sorry? You're in number? Oh, okay. I'm just giving general improvement of the experiment. Now, any other change? Yes, Cynthia? To reduce the temperature change. So wouldn't that interfere with the temperature we are supposed to read? Sorry? So what we are doing here, we are just checking to see what can be done to ensure that we get an ideal temperature measurement, okay, that has not been affected by the environment in any way. Okay? Are we together? So I still stand by her answer of saying that she's going to coat the whole system with a thermal resistance cover so that the temperature of the system remains the same without the environmental effects. Okay? Yeah. Now, why is it important to replace the bang in the conical flask immediately after adding the magnesium ribbon? Why is it important to immediately replace the bang in the conical flask immediately after adding the magnesium ribbon? Yes? Bang is the airtight lead that we put immediately after we put the magnesium. You see, we put magnesium and then we covered immediately. Why is it important to cover it immediately? Yeah, good. You know many answers. He has already given me an answer in that conversation. Huh? To prevent the loss of hydrogen gas from the conical flask. Yes?
Here they're saying to replace. Now, if it is this one, you put another one.
Which question is that? G. This is the monkey scheme even. Replacing just means you had it, okay, you had covered it, and then immediately you put the metal, you replace it. Like the moment you measure the hydrogen, the hydrochloric acid, yeah, you should cover it to minimize evaporation, if any, that will make your volume to change, okay? So they're asking, when now you put the metal, why should you replace it immediately? It's to minimize gas loss, yeah. Now you need to specify which gas you're minimizing its loss, okay? Which gas are you minimizing its loss? Hydrogen gas. So mention it. It will not harm you to mention that. Now state the advantage of measuring the volume of gas collected after 10 seconds rather than after every 20 seconds. Jessica? Yes? Higher accuracy. Is it accuracy that will improve because of doing it oftenly? No? Not accuracy? Yes?
Can you say at every 10 seconds so as to get the specific value? Because when you after 20 seconds, you're doing another range. So for specific value gotten after 10 seconds.
Now let me ask you, what was your experience drawing that graph, given that data was given to you for every 20 seconds? Huh? What was your experience drawing it? Hello? What experience did you have drawing the graph knowing that you have been given data for every 20 seconds? I think it would have been a smoother graph when you have more points to plot. Are we together? Yeah, you would have drawn a smoother graph when you have more points to plot. So more points, more data is better because it makes the graph smoother. Now, what did I leave you doing before I left? What were you doing? Yes? Now, I want us to make salts, and I want us to make pure salts. Now, how do you make pure salts? So let's go to the exercise book, please. Where is my duster? Please. Anyone seen my duster? Thank you. Thank you, thank you. Don't rub the investigations for today. Yeah. We are ready? Davis, we are ready for investigation 4? Okay. So the carbonate is in excess. Now, have you brought the filter papers and the filter funnels? Filter papers, filter funnels. And then we need to connect heat. Now you guys don't have a conical flask. You need a conical flask. Hey, hello. When it gets to 2 p.m., mutaniletea ORS. You have water? You don't? Just bring the sachet. So I'm taking after every 6 hours. So at 2, and then I'll take again at 8 p.m. And then I'll take again at 2 a.m. and tomorrow at 8. Thank you. I hope it's safe to take after every 6 hours. It's okay. Now, the investigation we are conducting is investigation 4, which is reaction of acid with excess carbonate. Reaction of acid with excess carbonate. Now, which carbonate have you been given? Calcium carbonate. And which acid? Which acid is this? HCl. Okay, thank you. Sorry? Okay. All right. So are we mixing this in a beaker or where? And the reaction? I would have preferred to do it in a, you know, the way carbonates froth and they, yeah. What about conical flasks? So we can't get an extra conical flask for, okay. Yes, I will. Actually, it's the next, yeah. Chemistry inaingia. I know. It's the pressure of learning a subject. The pressure of learning new things. Now, actually I've seen in 1.75, there is investigation 2, or rather objective 2, preparation of salts using excess metal and acid. We have already done that severally, isn't it? Now, can we prepare salts using excess carbonate? Now, the available carbonate is calcium carbonate, and the available acid is hydrochloric acid. Please note that down. I'm sorry, I thought it was not in the workbook. That's why I told you to go to the exercise book. But it's there in 1.75, the third objective. Mm-hmm. Mm. Now, step number 1. Good. What's in? Do you feel nausea? Can we excuse you from class? Can we excuse you from class? Excuse me. Please attend. Excuse. Come and attend to one of my students. Pass. Bill her. Bill her. Attend to her. Solubility. Let them just do in groups. Pairs. They can do in pairs. Huh? In pairs. So we demonstrate. Now step number 1. No, are we getting anywhere else to react this? Hmm? No, nimechoka kuzivaa. Sorry. Nimechoka kuzivaa. Now put the hydrochloric acid into the carbonate gradually. What have I said? Gradually. We are not fighting with. Hi. Hello. Habari yenu? Muko poa?
Unajua tukipa attend tomorrow like night ago imegomea 66.
Now the carbonate should be excess. So don't add until all of it has been diluted by the acid, okay? Just a little, and then you filter. So which salt is this? Hiya. Sorry? It was hydrochloric acid and calcium carbonate. I just need something to use. I'm using it to stir. Maggie, you'll set an exam. You'll set an exam for 2 hours. No. Let me come. Now, are we done filtering? We are filtering. Who does not have, which group does not have filter paper, filter funnel? Now we are filtering, and then we will heat to evaporate off the excess water until we get to the point of saturation. Until we get to the point of saturation, and then we crystallize. Have you followed the steps? What have I said? We filter, and then we will heat to evaporate off the excess water. And then we are going to get it to the point of saturation, and then crystallize, then dry the salt, and we'll have pure calcium chloride.
That's okay. A separate subject? No, I just a science paper. Science paper. Table, chart, matching this side and this side, you know, it's not about the complexity of the science. Yeah. So we assess them based on the things that we have learned. Yes. Then we mark. Alright? Actually, we will not mark. They will peer mark. We will peer mark as I go through. Then I collect the mark. And then we hit the time step. Enough hands. But simple you cannot. I just don't want one that will strain us and then revise me with them.
Okay. Where? Yeah, the process is a bit slow, but We are patient people.
Actually, huwa inatoboka. Huwa inatoboka. If you try to interfere with a filter paper, it caves in.
So where are we heating from? Okay. Now, do you have an extra boiling tube? Does every group have an extra boiling tube? Hey, no. Okay, now once you have finished filtering your salt, okay, you can come and heat it gently as you evaporate off the excess water, all right, until it gets to a point of saturation. How do you know that it has gotten to a point of saturation? It starts forming small particles on the side, okay? And that time now you allow it to cool and then form crystals. Now, after it has formed crystals, you can scoop the crystals and place them on a filter paper and allow it to air dry. Are we together? Now that will be a pure calcium chloride salt. So you will have prepared a salt using an acid with excess carbonate. You will have also undertaken a separation method, okay? And you will also have evaporated and crystallized. So those are several skills that you have learned within one investigation. Please let's fasten. You know, I've realized we don't even have time to finish the workbook. Huh? You have less than 24 hours.
I don't know why it's not connecting to Wi-Fi. It's not connecting to Wi-Fi.
Combustion. Let's just say she was learning combustion of nonmetals. But isn't this sufficient? Yeah.
Okay, what we'll do, that we are hitting to? No, we are hitting, no, we are not using the crucible, we are just using the, we are using the conical flask. Now this investigation should end in the next 3 minutes. Filter paper inatakanga kubembelezwa hivi. Now what's the color of your solution? Sorry? Amazing. Okay. Now, if you have collected at least, oh, this is little. This is little. Little. Hey, that's little, man. But that's an acid. And we are reacting with excess carbonate. Why do you want to spoil it? Just let it be. No matter the amount of salt you collect, it's okay. You have learned the skill, isn't it? Yes. The purpose is to learn the skill. Okay, is there anything collected here? Isn't that enough to allow you learn the skill? Yeah, the purpose is to learn the skill, not to make a lot of salt. Okay, my darlings? Yes. Where have sticky notes gone to? Switch off. Is it still on? Switch it off. Okay, let's move on to the next thing. Now, the next thing we are going to do is solubility of salts. Solubility of salts. Solubility of salts. Now that's the next table in 1.75. 1.75. So can you come here with your workbook so that we check on solubility of salts? Please come. You can leave one person heating, by the way. You can leave one person heating. We can't stop the class because of one thing. I told you we don't have time to finish. Imagine. Or we can do up to 4 p.m. tomorrow. Ha! You're joking.
I'm waiting for you. I want us to do solubility of salts. Now, I'll just follow the order in which they are in that table. Sodium, potassium, ammonium. That's ammonium chloride, sodium carbonate. I'm looking for potassium something, yes. So, I'm looking at solubility of these different salts. This is water. So I'm just using approximations. There is no, it's not a quantitative analysis that okay, so the first one is sodium carbonate. Color of the salt, appearance. So just a scoop. Okay. So this is sodium carbonate. Then the next one will be ammonium chloride granules. So ammonium chloride granules. Color and appearance is now the third one is a potassium salt, and this is potassium nitrate. Color, appearance. So what does that tell you of ionic compounds? Most of them from group 1 are crystalline, and the color is white salts. I think I'm done with the first row. Now, I'm not going to do for nitrates because I've done a nitrate there. Okay? Potassium nitrate. And then we have chlorides. Barium chloride. Barium chloride. Now, what does solubility of chlorides say? That most chlorides and iodides are soluble except silver, lead, and mercury. So that is barium chloride. So all these are salts, they are very safe. Even when you shake and it spills a bit on your hand, you're still safe. Just do not ingest, because we don't want you to ingest funny things. Okay. Sulfates, I'm looking for a sulfate. Now solubility of sulfates is, most sulfates are soluble except silver, lead, calcium, strontium, and barium. Wow. This is copper sulfate, our favorite salt. I like copper sulfate. If salts were pets, I would buy copper sulfate. Please label it. Can you imagine? You interact with chemicals until you start unaanza kuzinoki. Now, I won't do for carbonates because I did sodium carbonate. So we are just going to look at what it says, that carbonates, most of them are insoluble, except the ones for group 1 and ammonium carbonates. Now, which student is that facing that? Oh, you're still heating. Now, when it gets to the point of saturation, don't heat until it dries, please. When it gets to the point of saturation, leave it to crystallize. Then hydroxides. Here I have magnesium hydroxide. This is now a powder. These are not crystals, okay? In fact, you can mistake this for unga wa dola. Huh? You know unga wa dola? It's okay? Oh, 2080. 2080. So this is magnesium hydroxide. Then we have another sulfate here, ammonium sulfate. Ammonium sulfate. Where is my copper sulfate? Has it dissolved? Shake it. Hey. Ammonium sulfate. Huh? Can you hear? These are definitely. And it looks like sugar, by the way. Look. Ones who said you should not ingest and drink in the lab, they knew what they were saying. So this is ammonium sulfate, and the last one is sodium. Do we have to do for sodium chloride? Or you just want to see us do it? Who wants a salt to shake? Clarice, nimekuogopa. You take a filter paper and start burning it in the lab. You are? Okay. You are doing extra. This is sodium. Yeah. Sasa nikilipishwa nitafanya nini? Oh. So this is sodium chloride. Are you sure? Okay. Now I want you to return those salts here, okay? Then I'll place them somewhere central so that you can record each salt and whether it is soluble or not. Okay? So I'll place it somewhere central. Wow. So once you've shaken and shaken and shaken and you can't see any change, please place it here. Bring it here. Eh? Which salt is this that was not closed? Now that exercise should not take us more than 4 minutes, please. We are in the 43rd hour. We are running out of time. Okay, let me have the the boiling. Okay, amazing. So let's go back to our desks or our benches. Now I am placing this at a central place. When you get 2 minutes to spare, you come record the salt and whether it is soluble or not. Now let's take the shortest time, please. All the salts are here. Can I send you to go and check on your friend? Then you come and give me feedback because I can't leave. After it is saturated, allow it to crystallize. Just give it time to cool. Okay? Yeah. We are recording the solubilities of the salts we have just investigated.
In high school, we had acronyms for those.
Oh, you did?
Yeah.
Uh-huh.
So, like for chlorides,
Uh-huh.
we had something we used to call classic. All chlorides are soluble except lead and silver.
Ah.
And then for sulfates, we had like carbon. All sulfates are soluble except lead, calcium, and barium.
Uh-huh.
For carbonates, we had in carbosoam.
Wow.
So we had all carbonates are soluble except in carbosoam. So sodium, ammonium, and potassium.
Can I give you an opportunity to tell the class? Okay, now I have a professor of salts here. His name is Marlon Mwakio. Now I want to give him an opportunity to go to the board and show you what he used to do in high school to learn the solubilities of salts. Okay? Please welcome him with shangwe na vigelegele. Oh, but I can see crystals. You have achieved. You have met the objectives. Quite relaxed. See, umepata. See, these are crystals. Lenny, these are crystals I'm seeing. Just allow them to cool. They are crystals. Yeah. If you had more, that means if you had more, you would have achieved more. Yeah, so either way you have met the objective. Yeah. Please listen to... Okay. Please listen to Marlon. Shh. Sorry? Okay. Has group 1 come back? Okay. Group 2, health break.
All carbonates are insoluble except
sodium, ammonia. So we have sodium, ammonia, and then the last one was the nitrates. All the nitrates are soluble.
Wow, wow, thank you so much. Appreciate him. Finished recording the solubilities of salts. Now, about, yes?
What about
mercury?
Mercury chloride.
Where is it? Okay. Yeah, mercury chloride is insoluble. You have this book. The table is there. It's here. For chloride and iodides, mercury chloride and mercury iodide is there.
Yeah, it's okay. Her blood sugar low. Sugar levels.
So she needs to eat. Now can we go to the next page, the page after solubility of salts? Now preparation of salts using using insoluble base. Okay, we already did this theoretically, and because we have spent a lot of time investigating salts and acids, I would want us to move to other things. So allow me to skip that page, okay? Yeah, it's something you can handle. Maybe after 66 hours I'll decide to come back. Can I leave it pending? I don't know. So the next one I had requested to do, which we have not done, is 1.76. 1.76, we are preparing insoluble salts by precipitation. We are preparing insoluble salts by precipitation. And I have barium chloride and magnesium sulfate. Barium chloride and magnesium sulfate. This is barium chloride. Now I can use any other sulfate other than magnesium sulfate. Let me see. Okay, look here everyone. I want to prepare a precipitate, okay? And I am looking for two soluble. Hey, you are very creative. Three calculators.
So I want to make a solution of barium chloride, and then I make another solution of ammonium sulfate. Then I'll do a precipitation reaction. No, from there I'll guide you on what to do, okay? Now I need somebody here to come and make just a standard solution of ammonium sulfate, and someone from this side a standard solution of barium chloride. Let me get you some beakers. Yeah, just the small ones and the starring rods.
Starring rods, yes.
Okay. Okay, thank you. Yeah, I'm okay now. They don't look so clean. Let me use this instead. Thank you so much. Okay, so I'm giving you a beaker. Make sure you rinse your starring rod so that you don't contaminate your salt. Now, who is preparing the solution? Rinse that starring rod. Now, I want you to use up to 50 ml of water and 3 scoops. 3 scoops. Now, don't scoop as if you want the salt to end. Just standard scoops. 3 scoops of the salt. So let me bring you the spatulas. Spatulas. Just two. Yeah, it's okay, don't worry. Okay, now that should take less than 120 seconds. If this tap is not opening, open this one. Alternative solutions. 50 ml. Okay. Fifty ml. I said 50 ml. 50 ml and 3 scoops, both for both you and them. No, we are not calculating mass. We are just doing a precipitation reaction using 2 solutions. Okay. Have you understood the instructions? What is happening?
You want to make that standard solution.
Okay, I said use 50 ml water and 3 flat scoops. So I gave you a spatula, so you scoop, flatten 1, scoop, flatten 2, like that. So the others are still doing the same as well. Yeah. Sorry? Oh, they just sikuwa najua what you meant. It's hers. Oh. Okay, now I need the 2 solutions mixed in a bigger beaker. I need a beaker. Now, are the two solutions ready? Now, you have not yet shown me your crystals. So this is pure magnesium, no, pure calcium chloride, all right? Yeah. Congratulations for preparing a pure salt. I need a bigger one. Okay, just one. Thank you. And then filter paper, funnel, filter paper and funnel. The rest will. Can we get distilled water or we just use tap water? Now, can I have the two solutions here, please? Let me have the two solutions here. Yes. So which solution is this? Yes? Barium chloride. Okay, give it to me. So this is barium chloride and you guys have ammonium sulfate, right? You have ammonium sulfate. Let me have the solution. Okay. So now what is a precipitation reaction? All eyes here, please. What is a precipitation reaction? It's a reaction involving two solutions, okay, that react to give one soluble and another one insoluble. The other one that is insoluble is what we call a precipitate. Now, I'll move here. Probably you'll all be able to see here. So this is barium chloride. And this is ammonium sulfate. There you go. So the white insoluble salt is now what? Huh? Let me send someone to the board. Let me send my scientist here. Can you go and write the word equation for this reaction so that we know clearly what the precipitate is? Barium chloride and ammonium sulfate to ammonium sulfate.
This chloride is displaced by this sulfate, so it will form. So barium will react with sulfate to form a insoluble salt, and chloride and ammonia form a soluble salt. So this is barium chloride. It reacts with ammonia sulfate to give you.
Hey, scientists, you're overthinkers. Ay. What did I send him to do on the board? What did I send him to do? No. Which equation? What equation? Look where he is now. I told you to write a word equation, Harold.
Equation. Okay.
Now, they are almost calculating moles.
Okay, so let me write a word equation.
As earlier instructed.
So, sorry for kukuwa na kirere mingi. So, will I write really?
Look at how you're taking your sweet time, and I told you we have less time remaining. Okay, thank you so much. Let's appreciate him. So that means that because we said all sorts of ammonium are soluble, then that means the precipitate we have here is what? Barium sulfate. And if you look at the solubilities, it's clear there that barium sulfate is an insoluble salt. Now I want us to filter this. Rinse it. Remember, we are working on learning the skill of producing pure substances. Like we just produced pure calcium chloride here. Let me show them. This is pure calcium chloride. Okay? Unless anything else entered, it has no impurities. Are we together? Yes. All right. So I want us to filter this. I thought they gave me, okay, yeah, she did. I'll need a conical flask. Yes, another one to filter the mixture. Okay? Now, what is the filtrate? Ammonium chloride, and what is the residue? Now, you should be in that page writing now. Looks like milk. Now you should be in 1.76 writing. Now you can cancel, instead of magnesium sulfate, just cancel magnesium and replace with ammonium. Cancel magnesium and replace with ammonium. Now write the word equation as Haron has written on the board, and then I think I'll call Chabi to write the balanced symbol equation for that precipitation reaction. Okay? That is after we write the word equation. Now, in 3 sentences, just write the steps and procedure that we have taken. The observation, okay? We have seen formation of a white precipitate. Now, how to collect the insoluble salt? What am I doing here now? I am filtering. And then any other case study, we are not doing another case study. So We said we must work on our speed. Can see it's working. After this, we go to what most people have been waiting for. Titration. Just, I think, 2. I'm sure you're ready for titration. Amazing. Yeah, just 2. Now I'm still filtering my barium sulfate. Now, what steps should I take to ensure that it is pure once I finish filtering? I should wash it with distilled water. And then what else should I do? I dry it. There are several methods of drying salts. Give me the methods of drying salts. Yes? Using filter papers, using paper towel, air drying, or oven drying. Now, what is the disadvantage of oven drying? It's going to cook. Hey. Yes? Yeah. Hey, you are a scientist. Give me a high five. That's not a high five. Anyway, it will decompose. Thermal decomposition as a result of high temperatures. Okay? Now, we are going to do quantitative analysis where we are going to find concentration by titration. We have calculated concentration by calculations. Now I want us to do it experimentally, okay? Now in this example 1, which is the one we are about to set now, you are asked to find the concentration of a solution of hydrochloric acid. Thank you, Chebi. Now, if you are unable to write the balanced chemical equation, for the precipitation reaction, please refer to the board. So in this example, you are asked to find the concentration of a solution of hydrochloric acid using a 1 molar solution of sodium carbonate as the standard solution. So you are going to titrate the acid against your standard solution. So the first thing you do is measuring 25 centimeters cubed of sodium carbonate solution into a conical flask using a pipette. Now we are going to give you all this. We'll give you the sodium carbonate solution, conical flask, pipette, a few drops of methyl orange indicator, okay? And then we are going to calculate the volume used by subtracting final level minus starting level. Make sure you save the marking scheme so that we pitia quickly. You save PDF and save the marking scheme. These are adults, they can even be a mark as we supervise. Now, make sure you rinse that burette with the acid first. Standard procedure, because we don't have distilled water, rinse that burette with the acid. Maggie, you can access my letterhead from. Now, all I want you to call me to show me is starting level, which is 0, 0, 0, 0, 0.0. And then the final level, and then the volume used. Then once we have the data, I want us to calculate the number of moles, like to do step 1 to step 4 together. Msinimwagilie hii.
Acha tuweke hiyo side nyingine. Waweze tatua.
Group. So definitely 3 is the next and 4 is the next. Now, why do we rinse apparatus before we start? Why do we rinse apparatus before we put any reagent in them? Yes, Marlon?
To avoid any intoxications of reagents.
Intoxications? Hey, scientists. Okay. Let me take it as a correct answer. But basically, what are we avoiding? Contamination.
There's a okay. What do you do?
Okay, can we now move to example 2 as we wait for the reagents to be supplied then? Is that a better plan? Okay. Who has my book there? Somebody has my book. Okay. Now, can we all look at example 2? Example 2 still on titration. Example 2 still on titration. Now let's go through the example together. Excuse me. Let's go through example 2 together. Vinegar is mainly a solution of the weak acid ethanoic acid. 25 centimeters cubed of vinegar were neutralized by 20 centimeters cubed of 1 molar sodium hydroxide solution. What is the concentration of ethanoic acid in the vinegar? Sorry? Concentration of ethanoic acid in the vinegar. Now, the first step is to calculate the number of moles of sodium hydroxide used, and we are going to refer to which triangle? Yesterday we were drawing a certain triangle so many times. Which triangle was that? Have we forgotten? So we are going to use the concentration triangle. Now what do we have here on top? Sorry? Mass? No. Moles. 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 And then we have concentration times volume. So for this case, for sodium hydroxide, we have the concentration of 1, okay, times the volume of 20. But am I going to use it as 20? What is wrong with multiplying this way? Huh? It's in centimeters cubed and it's supposed to be in decimeters cubed. So we divide by 1,000. So we have 0.02 moles. So the number of moles of sodium hydroxide used is
0.02. Now, have they given us the equation? Have they given us the equation? Okay. So somebody go and write for us a balanced equation for ethanoic acid plus sodium hydroxide to give you sodium ethanoate plus water. Remember, this is a neutralization reaction that involves a weak acid and an alkali. Someone go up to the board and write for us that equation. Ethanoic acid plus sodium hydroxide to give us sodium ethanoate plus water. Jelimo, are you able to do that? The products are sodium ethanoate plus water. It's a neutralization reaction between a weak acid and an alkali. So we'll get salt and water. Sorry? You can try. Every time you try, you get it right. So can we finish up on step 1? Oh, sorry, I keep on sitting on your position. Sorry? For sure. Now, the most important thing we are supposed to get from this equation is the mole ratio, okay? Isn't it CH3COOH? Yes. No? Ethanoic acid. So it's CH3COO, yes, CH3COONA. Okay, let's do it together. Let's do it together. You see it like this, yeah? Mm-hmm. The anion will be this, the ethanoate. Yeah, so sodium will just... So that's the salt plus water. Then you balance it, and it's already balanced if I'm not wrong. Thank you for trying. Now, what's the mole ratio for this? 1, 1, 1, 1. And what's the number of moles for sodium hydroxide? 0.02. So that means that the acid that was neutralized was also how many moles? 0.02, because the mole ratio is the same. I believe we have answered up to step 3, if I'm not wrong. We have answered up to step 3. Great. So then, see now, we now have the volume of the acid. We have the number of moles of the acid, and now we are being asked for the concentration of the acid. Very simple. Please refer to the concentration triangle. You look lost. No. You're okay.
So we have this, and this is, what is it? Is it 25? Yeah, 25 over 1,000. So then it's so easy to find this because it's 0.02 divided by 0.025. Please give me the concentration. 0.8. 0.8 molar. So in this kind of titration problems, we work from known to unknown. Are we together? Now the most important thing when it comes to this is to be able to write a balanced and a correct symbol equation. Because if you get it wrong at the equation level, you'll get it wrong in every other step that follows. So let's finish that, and I'd like to know when we are ready for the titration. Now we are done with the examples. Now we have a problem there, problem 1. Now group 3, please go for your health break. Group 3, go for your health break. Thank you. Now can we attempt the problem? Attempt the problem in 2 minutes. Yes? It's okay. Okay, what is it called? Okay, it has the functional group COOH, okay? And then it has, so because it's ethanoic, it has 2 carbons. No. Let me confirm and then I let you know. I have a book here. Are we done with the problem? Darlene. Yes. Okay. Can someone go up to the board and do the problem for us the way they have done? Bramwell, thank you. Rub all of it. Now, if you have been unable to do the problem by now, please pay attention. He's guiding us through the problem 1. Where is the microphone? We need to hear what he's saying. You know the question of head. So, okay. Pay attention, eyes on the board, please.
So the question reads 20 cubic centimeters of 1 molar sulfuric acid were neutralized by 25 cubic centimeters of ammonia solution. Calculate the concentration of the ammonia solution. Then you have been given the chemical equation. So we have been given the molarity of sulfuric acid, and also we have been given its volume. So the molarity of sulfuric acid, it's 1 molar, and as well as its volume, it's 20 cubic centimeters. So we shall use the concentration triangle, moles times volume. So to get the number of moles that reacted with ammonia of sulfuric acid, we shall take that molarity, which is 1, then we multiply by the volume after we convert it to decimeters, which will be 0.02 decimeters. Which is
cubed.
Which is 0.02 moles. Then we shall compare the mole ratio at which ammonia and sulfuric acid reacted, and it's 2:1. So 2 moles of ammonia reacted with 1 mole of sulfuric acid, and we have the number of moles of sulfuric acid that reacted. So we shall just cross multiply to get 2 moles times 0.02 divided by 1, which is the same as 0.04 moles. These are the moles of ammonia that reacted with sulfuric acid. But the question is asking us to calculate the concentration of the ammonia solution. So having the number of moles and we have the volume of ammonia that reacted, we can get the molarity, rather the concentration. And concentration is equals to number of moles divided by the volume. And the number of moles is 0.04 divided by the volume, which is 25 cubic centimeters, but we shall have to convert it to decimeter cubic, which will be 0.25.
0.025. You guys, you're not seeing that mistake? 25 divided by 1,000. 0.025.
What answer do you get? 1.6 molar.
How many had gotten that before he went up? Nobody. Oh, okay, okay. Let's appreciate him for that. Okay, I want us to do problem 2 together. So as you finish copying what is on the board, we are going to do problem 2 together. So we are looking at methods of preparation of salts, the reactants we are using, the salt formed, and any other products that will be formed from that reaction. Okay? Now, I think since yesterday we've been doing a lot of simple chemical reactions, both theoretically and practically. So it's very easy for us to fill this table. Now, A, acid plus alkali. Here we have calcium hydroxide. Okay, A has been done for us. Let's look at B. Acid plus metal, for example, zinc and hydrochloric acid. Which salt is going to be formed there? Yes, someone raise your hand and let us know. Yes, Sarah? Zinc chloride. And any other product that will be formed? Any other product from that reaction? Yes, Bramwell?
Hydrogen gas.
Hydrogen gas. We are in problem 2. Okay, question C. We have an acid plus an alkali. And from this reaction, we got a sulfate. So which acid did we use to get a sulfate? Clarice? Huh?
This is sulfuric acid.
Potassium sulfate. Which acid gives us a sulfate? The sulfuric acid. I want you guys to stop overthinking. Yeah. Okay, D is a reaction between an acid and a carbonate, and we are getting sodium chloride. So which carbonate are we using in D? Sodium carbonate and hydrochloric acid. Now we are getting sodium chloride, water and CO2, carbon dioxide. Yes. Those are the other products. Now, E again is an acid and a metal. For you to get iron 2 sulfate, what have you reacted there? Iron and sulfuric acid to get iron 2 sulfate and hydrogen gas. We are in E. Now, F. Acid plus dash. Now, when you look at the reactants, what is nitric acid? It's an acid, and then sodium hydroxide is an alkali. So it's acid plus alkali to give us sodium nitrate plus water. Sodium nitrate plus water. Then we go to G. Acid plus insoluble base. You see what I was telling you guys? Yeah? Metal oxides that are insoluble are referred to as insoluble bases. So we have acid plus insoluble base. The acid here is sulfuric acid plus copper 2 oxide gives us copper 2 sulfate and water, because it's a neutralization reaction. Acid plus base gives us a salt and water. Now in H, we have copper 2 sulfate formed and we have carbon dioxide. So that means that this is a reaction between an acid and a carbonate. So which acid is this? Sulfuric acid. And which carbonate is this? Copper carbonate. Which other product is formed from this reaction? Water. Let's all focus on problem 3 now. Problem 3. Are we all in problem 3? James has performed a titration with 25 centimeters cubed of 0.100 mole per molar of sodium hydroxide solution, which was neutralized by exactly 20 centimeters cubed of a dilute solution of hydrochloric acid. What is the concentration of hydrochloric acid? Now the first thing we are going to do here is to write a balanced equation between what and what? hydrochloric acid plus sodium hydroxide. Now this one is normally balanced already. Okay? So it's aqueous, and liquid. Okay? So what is the mole ratio for problem 3? Yeah, everywhere is 1, 1, 1, 1. So we start from known to unknown. Now we have more details of sodium hydroxide than we have of hydrochloric acid. So using the concentration triangle, where we have moles over concentration times volume, the concentration of sodium hydroxide is 0.1 molar times the volume, which is, are we all there? What is the volume? Alvin, what is the volume of sodium hydroxide? Sorry? 25 over 1,000. Okay? So we are dividing it by 1,000 because we must convert from centimeters cubed to decimeters cubed. Are we together? Yeah, so we have 0.1 times 0.025. So this is 0.0025 moles. So if this is 0.0025 moles, then this is also 0.0025 moles. Again, we use the concentration triangle. Now we already have moles as 0.0025. We already have volume as 20, but because we are converting to decimeters cubed, what is the volume in decimeters cubed of hydrochloric acid? 0.02 times now what is unknown, which is the concentration. So concentration equals 0.0025 over 0.02. What's the concentration there? Sorry? Now, is there anyone who still does not understand the steps we follow to calculate concentrations, volumes, and moles? Now, the next topic, I'm wondering whether I teach it now or at night. Hey, we'll do this at night, please. I also don't have energy. Anyway, let's go to sexual reproduction in plants, 1.78. Sexual reproduction in plants. Now, I want to send 4 students to bring us specimen of flowers from our environment. Damaris is already up. Marlon is already up. Lucy is already up. Some people have gone like 3 times from the time I've been. Come with many flowers, okay? Take not less than 3 minutes. Clarice, if you're going, run. No. The class should not have less than 10 students at any given time. You want the record to end now? Now, what do you know about flowers? Without looking at the diagram I have printed for you. What do you know about flowers? Huh? They have a good scent. Huh? Alvin, what do you know about flowers? They are colorful. At least I know I love flowers. Huh? Somebody knows that she should have been given flowers yesterday, but she was not. At least we know something about flowers, isn't it? Now, the diagram you're seeing there is a longitudinal section of a flower. Now, I don't like referring, as much as I have printed it for you, I'm not going to refer to it unless I have to. Are we together? I'm going to refer to the one that will be brought here live. Rife. Okay? Yeah, so the specimen that will be brought, we are going to cut it longitudinally and try and get such now physically to refer to label and all that. So I hope they get the best species of from the best species of plants. Now, what is pollination? We can define pollination as we wait for them. Pollination. Yes? Mm-hmm. You have spoiled your answer by the last statement. Your answer was correct until you said the last statement. Mm-hmm. Yes. Pollination is transfer of pollen grains from anther to the stigma. Now we have self-pollination. Self-pollination is when a flower pollinates flowers within the same plants. Okay? A flower pollinates flowers within the same plant. Have you gotten the letterhead? Have you gotten the letterhead? And then we have cross-pollination, where pollen grains from a flower of a different plant are transferred to the stigma of a flower of another plant but of the same species. So if pollen grains move from maize to grass, are they from the same species? No, so you can't say that that is cross-pollination. It has to be between plants of the same species. Now, why do you think pollination is important? Yes? So that fertilization can take place. You can edit. You can edit. Just a minute. You can edit. So you'll do a cover page like this one. We'll do a cover page like this one. Longest science lesson examination compiled by Tata Wekesa. So the letterhead and whatever remains. Okay. Now I was asking about the importance of pollination. Okay, wow. I like. Marlon, where are the specimen you have brought for us? Okay. Okay, thank you. Now we have different flowers here. So it doesn't matter how big the flower is, as long as when you cut it longitudinally, okay, you can be able to label all the flower parts. So I don't know how many flowers these are, but we can work in pairs. So please choose one person from your pair to come and pick a flower. I won't distribute because I don't know which one you like. Send someone from your pair. Just pick one flower. Scalpels and tiles. Now I want you to dissect that flower longitudinally and identify the parts. Identify the parts of that flower in reference to the parts of the flower you have in your workbook. Thank you so much. Even the tiles are to a limited number, so you want to distribute? Okay. So they are working in pairs. They are working in pairs, so when you identify a pair, you give them. Now please don't cut on the bench. We do not intend to cut on the bench. Use the tile kindly. Dissect. Now, only draw what you see. Do not force a flower to have all the parts. Are you together? Yes. Only draw what you see. At least you have one that has all the parts. So there is nothing really to worry about. Now, is my barium chloride still, barium sulfate still filtering? Or you guys poured it? They took it. Ah, no. Yeah? Ndio. So let that activity take us 3 minutes. Clarice has come with more flowers. Bramwell has come with more flowers. At least even if we didn't get flowers yesterday, we are still safe. You need more than 10 when you leave. No, I'm asking, you need more than 10 when you leave. If you assure me, then we can go. Okay. Okay. We are cutting flowers longitudinally. Now I allow you to give somebody of your choice a flower after you are done drawing the flower. Najua ni poa pia kujitetea kiplani. Eh? Oh, thank you. Picha.
Hii ndio maua sasa, achana hiyo. Hii ndio maua.
Ah? Sorry. Group 4. Okay. Have group 3 come back? They are back? Okay. Group 4, please go for your health break. I have missed you. You have just come from your break. Group 4, go for your health break, please. Wherever you are comfortable. Even if you want to stick it with tape, it's okay. Inakuanga tu mpoa. If you feel like sticking it will save you time and stress, just stick it. Find space and stick it. It will just dry there and it will still be there. It's the same.
The same. Is it the same or different?
I don't have the figures offhand. I don't have the figures offhand. Just check from somebody's book. You guys, you need to quicken thy steps. Do you have a tile? Do you have a scalpel? Cut the flower, draw it or stick it. Now, we agreed that we'll not be putting clothing on the bench. I can still see hoodies. I see lab coats on the bench. Please, when you'll be crying that your hoodie has gotten acid, I won't be there. Please take care of the apparatus. Take care of the apparatus. Maybe fruits na hiyo waresi nilikuwa nimewambia waniletee saloni. Wakuleta? Yes. Wow. Guys, I'm not seeing progress and I am getting impatient. Why don't you just stick these flowers, you guys? Please, take tape and stick them on the book or in the book.
Even this I need to
Now remember, you still have a model of the heart to submit and earn marks from it as a group. You're done? Now, you have decided to stick on top of the one I printed for you, surely?
I was matching the
Yeah. I'm not, because I also don't want to keep taking breaks to go to the bathroom. So when I know my break is in 2 hours to come, ninachapa 4 hours bila maji, and then I'll start sleeping in 2 hours to it will complete it. Thank you. Thank you so much.
What of this?
Where Maston?
Yes.
Now, we finished sticking, now we are labeling, and also, as we are labeling, we are discussing the parts of the flower and the function. All that we are doing it on one page, please. Within the same page, all those things should fit. Have you cut the flower longitudinally?
Let me just.
So pick on the
So they have a little.
most of the petals are colorful. They have bright colors that are attractive to the pollinating agents such as bees.
Okay. So the work of the petal is to attract pollinating agents such as bees. Now, another function of petals is to protect the sensitive inner layers. To protect the sensitive inner layers of, by covering them. They are not exposed. Most of them are not exposed. Okay, now the other part I want to talk about is the flower stalk. Someone? Function of the flower stalk. Function of the flower stalk. Sarah? Holds, anchors, or rather supports the flower in an upright position. Okay. Another function of the flower stalk. Yes, Chebi, you've not spoken for some time. Transports nutrients to the flower, yes. Now the other part is the okay, let's discuss the female part of the flower. And that's the reason why we are actually talking about sexual reproduction in plants, because flowers have both male and female parts. Are we together? Yeah, so now what's the general name for the female parts of a flower? Hey, for once you've raised your hand. Clap for him. He has started raising his hand. Yes, Haron, yes? Pistil or? Pistil or? Oi. Carpel. Carpel. Now the carpel has several parts, and I'll start with the stigma. We have 4 parts in the carpel. The first one is the stigma, the one we talk about almost all the time when we are talking about pollination. Okay? So what does the stigma do? What does the stigma do? Imelda? This is where pollination takes place, okay? And even the pollen tube germinates from there and then goes down through another part called the style, okay? Now the style is still part of the female flower parts. And what is the function of the style? Function of the style. Yes, Bramwell. The style is where fertilization takes place. Good. Wewe unatudanganya na unafanya nirudie. Now, please don't go to fertilization now. I want other people to say something. Damaris, style.
transports pollen to the ovary. That is correct. But instead of using transport, we can say allows growth of the pollen tube. This is where the pollen tube grows. Now the pollen tube is the one that carries the male nuclei to the ovary. Now it has two functions. What's the other function of the style? Yes? Lenny, what is the other function of the style? Sorry?
I'm not sure about mine.
Uh-huh.
Can you say example
Yeah, not can you say. That's the correct answer. Doubting yourself again. Hmm? Okay, then after we go down to the style, we have the ovary. What happens in the ovary and what is in the ovary? Gidi. What happens in the ovary and what is in the ovary? You know, there's something I've realized about this class. I don't know if you've realized it yourself. Every time you doubt your answers, the answer is normally the correct one. But the time you have more confidence, that is when... So, Gidi, tell me what is in your mind. What do you think is in the ovary and what's the function of ovary? Yeah, it's correct. Because where else would the ovules be if not in the ovary? Now, another thing is that the ovary also makes them. Makes the ovules. Now, when a plant matures and fertilization takes place, what does the ovary become? Becomes the fruit. Yeah. So when you're eating a fruit, you're eating an ovary. Gosh. Hey, when you think about it. Okay, and then lastly we have the ovules. What are the ovules and what do they do? Cynthia? What are the ovules and what do they do? Sorry? Yeah, this is where fertilization takes place, and the ovules contain the female nuclei. Okay. Now let's go to the male parts of a flower. And I'd like to know the collective name for the male parts of a flower. Collective name for the male parts of a flower. Marlon. Stamen. Where Maston. Tell us the function of the anther.
It produces pollen grains.
Produces pollen grains. Then filament. Someone tell us the function of the filament. Now where is Brian? Oh, okay. You're the one I'm looking for. What is the purpose of
filament. Sorry? Supports the anther. Now, which part haven't I mentioned? We have the nectary that produces a sticky, sugary substance that has a sweet scent. For what? For attracting insects and birds for pollination. Then we have the sepals. The sepals are the tiny leaves beneath the flowers, and their work is normally done the day the flower buds, because that is when they are pushed away. That is when they are pushed away and the flower takes the glory. But before the flower matures, it's the sepals that protect the flower. Okay? Right. Now, once you're done writing the parts of the flower, I'd like you to continue working on your model for about 3 minutes. Only 3 minutes. Just go to where the model is, work on it. Model of the heart. Yes?
Receptacle, what does it do?
Or receptacle is the one that now join where all the organelles, not organelles, all the parts of the flower
are
yeah?
conjoined.
Yes. If you need any insight concerning your model, let me know. It's so sunny outside. So sunny outside.
Wow.
45 hours. more minutes to work on your models. Now, get sticky notes to label. They are sticky notes. Yes. So make sure your model has been labeled. Make sure your model has been labeled. Now, when I go for my break at 4:30, the people who remain, I want you to organize all the models we have made during this lesson along these benches, okay? Kindly, it's a request. Sorry? Now, you shouldn't destroy a model you've made. Huh? Surely. Eish. Zama. How are you, Zama? So.
Dole nuko huku. Nikuandike jina. Ama uko hapa.
Doorline. Hey, what a name. Doorline. Okay, now time is up for the models. Let's put them away. Let's go to seed dispersal. Oh no, before we go to seed dispersal, sorry. Can we discuss a few pollinators? All right? Now, what are agents of pollination? And I need examples. Agents of pollination, yes? Animals, such as bees. Animal pollination. Is there animal pollination?
Insect pollination.
Yeah, insect pollination. Hey, you almost made me doubt my biology. You know the way he's telling me with confidence, animal pollination. Oh, Maston?
We are wind.
Sorry?
Wind.
Wind pollination. So, insect pollination, wind pollination. Another one? Bird pollination. All right, now what are the characteristics of insect pollinated flowers? Characteristics of insect pollinated flowers. So We are discussing them as we write them. I won't give any more time to write them, okay? Characteristics of insect pollinated flowers. Chebi? Sorry? They have nectar, good. Now what is the function of nectar? What's the purpose of nectar? Sarah, you've gone quiet all of a sudden. Doline. The purpose of nectar. Oh, yes.
Nectar is
I'm asking, what does nectar do? Sorry? No, like what's the purpose of nectar in a flower? To attract insects. Basically to attract pollinators like birds and insects, okay? Another characteristic, yes, Cynthia?
They have large and brightly colored petals to attract pollinators.
Yes, insect pollinated flowers have large, brightly colored petals to attract pollinators. Good. Yes, Malam?
They have a lunar female reproductive organs than the male ones. They have a longer system than the sun, so as to facilitate insect pollination.
Now, how you can say, you know, when you use longer, it sounds funny. Anyway, you can say that the female reproductive parts of a flower are exposed, okay? Are larger and exposed compared to the male reproductive organs. So this is basically to facilitate pollination. All right. Now, can we discuss the wind pollinated flower? Wind pollinated flower. Sarah?
The anthers are long and loosely hanging outside to facilitate the blowing of the pollen grains.
So the anthers and the styles, isn't it? They are loosely attached to the flower to allow them to be blown around by the wind. Yes, Bram?
They have a feathery stigma.
They have a?
Feathery stigma. To trap pollen grains that are like being blown.
They have feathery stigma to trap pollen grains. They have feathery stigmas for trapping of pollen grains as they are being blown by the wind. Now, what about color? Comment on the color, comment on the size. Yes?
They have dull colors.
Yes, they are dull colored because they do not need to attract any animal for pollination. Yes? There? Yes, they have, the pollen grains are light and large. They are tiny and dust-like. Tiny dust-like pollen grains. Okay?
Can I see that the anthers are above the stigma?
The anthers are above the stigma. Yes, 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 yes. So that when the pollen grains fall off the anthers, they can get to the stigma. Then the stigma, as much as they are below, they have feathery-like shape. They have feather-like shape. All right. I think we have exhausted that one. Now, from what I am seeing, the people who went outside, they only brought us insect-pollinated flowers. So, which one is? Oh, as long as it's brightly colored, it's insect-pollinated. Yeah. Now, I want to send 2 people who did not go. Did you go out? Did you go out? Huh? So you and one more person. Diana, did you go out? To get dull wind-pollinated flowers. So go out and bring for us species of wind-pollinated flowers. In 3 minutes, you should be back here with as many species as possible. Wind-pollinated flowers. So that we look at them. Don't just talk about things we have never seen. It's better than fish. All the best. Take us a photo. I must hug all of you before this lesson ends. Huh? For your perseverance and endurance. I looked at you the first day, I was like, hey, hey, hey. Huh? Kwanza Clarice, actually I was looking at her, I was like, woi. All right. Now, what is seed dispersal? What is seed dispersal? Seed dispersal. Guys, can we jog our minds quickly? Okay, stand up, we stretch. Yeah. Everyone is stretching, even the one seated at the back. Who is helping us to stretch? You know, Miss Maggie, we are all stretching. Why do you think you are an exception? Even the security is stretching. How do we stretch now? Aya, let's follow Trish. Tuite pesa ama. Hey. It's hey, Javan unafanya? Hey. Aya, tutakatwa time. Sit down, we continue learning. I'm sure we are now awake. Now, what is seed dispersal? Seed dispersal, seed dispersal. Seed dispersal and the function. Hey. Movement of seeds from one environment to another so as to find a suitable surrounding for growth and development. Yeah. Now, why should seeds be dispersed? By the way, you guys, you have to learn how to write as the point is being said. Clarice, say your point again. They will write.
Seed dispersal is the movement of seed from a certain environment to another environment in search for suitable conditions for growth and development.
Ah, great. Now, come and write on the board, Clarice. Now, as she's writing, I want you to think about why is it that seeds must be dispersed and what would happen if seeds were never dispersed. Okay, now, this is amazing. Oh, this is amazing, amazing, amazing. Huh? Let's clap for them. Wow. They have brought for us wind-pollinated flowers. Hey. Now, are these going to be enough to stick in our books? Now, let me extract them for you. So you come and pick and stick with tape. Oh, yeah, I hope they are going to be enough. Okay, not everybody will stick. You can come. Feel free. Now feel free to come and, extract even if it's a little part of a flower. At least have some specimen with you. Huh? Real specimen in your book. Please come and pick here. Come and pick here. Can you continue extracting for them? Continue extracting for them. I'm just wondering. There's no toilet in here. Ukiona Dr. Magu. Now I asked you to think about what would happen if seeds were never dispersed. Have you thought? Mm-hmm. Oh, don't stick the insects. Okay, what do you think would happen if seeds were never dispersed? Yes? There would be extinction of certain species because of what? Extinction cannot just happen. Sorry?
Because of non-dispersal.
Because of non-dispersal. Yes. Like, what's the disadvantage of seeds not being dispersed? Overcrowding, which leads to competition of space, food, nutrients. Then spread of diseases is rampant. Are we together? Now imagine if a certain species of plant, I want to explain her point. If species X is in region Y, and then an earthquake, like, for example, happens in region Y and everything is buried. If no dispersal had taken place, that is how the species stops existing, okay? So actually, I feel like dispersal is a way, like a form of ensuring continuity. Are we together? Yes, so seed dispersal, you've mentioned that it's movement of seeds from one environment to another in search for suitable conditions for growth and development. Good. Now, I want us to talk about the agents of dispersal, agents of seed dispersal. Now, these seeds are moving. How do they move? When do they move? What makes it easy for them to move? Do they have adaptations that make them go wherever they go? That's what I want to hear. Yes? Wind dispersal, yes. Now explain something about that.
There are some seeds which are light. They are light, so they can be easily carried by wind.
Yes, so wind dispersed seeds are light. They are dry. Okay. Some have wing-like projections. Some have wing-like projections that makes it easy for them to be moved from one place to another by the wind. Let's talk about another mode of dispersal. Yes, Cynthia? Animal dispersal. This one comes in many forms, yeah? Can we discuss them as we write? Sorry? Some have hooks, for example. The common one is blackjack. Sorry? Oh, we have a blackjack here. My desk could. You came with it and put it there. Oh. Yeah, this is blackjack. This is actually a seed. Okay, it's even falling, but... Okay. Which other ways do animals disperse seeds? Yes? Through their fecal matter. So when they feed on fruits and then they ingest the seeds elsewhere. And birds are actually one of the animals that does this the most. They eat fruits with small seeds like tomatoes, and then they go and ingest them elsewhere. So that is another way of dispersal. Now, what about humans? How do humans disperse seeds? Yes, Harold? Some of
the fruits are edible, so
Mhm.
when they will transport from one place to another. So
Mm. Even through importation and exportation of fruits, you find that seeds are able to be moved from one country to another. Now let's go to another agent of dispersal. Another method of dispersal. Yes, Clarice? Self-explosive mechanism or self-dispersal. Now, which plants are majorly dispersed through this method? Yes. Legumes, or basically plants that form what? Fruits in form of pods. So when they dry, they shrivel and the seeds are scattered to another location. So that's self-explosive mechanism or self-dispersal. Let's continue. Any other? Sorry? Jacaranda. How does the jacaranda seed look like? Sorry?
Okay, it has it's like a seed, not a seed, but it has an outer casing, but where when it dries, it cracks and cracks, and then the seed.
That is self-explosive. So does it dry and then pressure from inside causes it to expel the seeds? That is self-explosive mechanism. Okay? Have we exhausted them? Water dispersal. Now, which fruit is common for being dispersed? Or which seed is common for this? Sorry? Seeds that are buoyant. I'm asking for an example.
Coconut.
Yeah, the coconut seed, which has an airspace inside that causes it to do what? To float in water. Now, some seeds are water resistant. So even when they find themselves in a water body, they do not rot, they do not soak in the water, they do not sink. So they are able to be dispersed from one place to another through the movement of the water. Now, I don't think I want to discuss that further. Okay? Now, let's go to respiration. Respiration. Now, we are going to combine respiration and gas exchange. So you can add that on your workbook, respiration and gas exchange. Now, our respiration is the process by which living things obtain energy from food or from nutrient molecules. The process by which living things obtain energy from nutrient molecules. Now, I want us to discuss why is it that living organisms require energy. Why do living organisms require energy? Why do you need energy? For movement. Good. Movement is the first one. Why do we need to move again? Is it a must we move? Huh? Is it a must we move? Yes. Lazima tuende kuenda. Anyway, we need to move to in search for food, livelihood, security, spirit of adventure, A, and to escape harmful stimuli. So, another reason why we need energy is to be able to make protein molecules by linking amino acids together into long chains. I repeat, to be able to make protein molecules by linking amino acids together into long chains. The third reason why we need energy we need energy for cell division and repair of damaged tissues and growth. We need energy for cell division, repair of damaged tissues and growth. Oh, by the way, it's hot. If you feel like removing your lab coat, you can remove. We are not doing any practical until it's night. Okay? Hapo ndipo mnasema asante pia. Please fold your lab coat nicely. Now, another reason why we need energy is for active transport. Now, do you remember the definition for active transport? We said that active transport moves molecules from a place of what? Low concentration to high concentration using what? Energy from respiration, isn't it? And then, of course, with the help of protein carriers. Yeah, so active transport is one of the main reasons we also need energy. Now, another reason for energy is transmitting nerve impulses so that we can transfer information quickly from one part of the body to another. Transmitting nerve impulses so that we can transfer information quickly from one part of the body to another. And lastly, we need energy for production of heat inside the body. We need energy for production of heat inside the body. For purposes of keeping the temperatures internally as constant as possible. Purposes of keeping temperatures internally as constant as possible. Now, the main nutrient that we use for respiration is glucose. Okay? Now, glucose is a monosaccharide, which means that it is a simple sugar. It is a simple molecule. And respiration basically means that we break down the glucose to release energy and other substances. So we have two types of respiration. We have aerobic and anaerobic respiration. I want us to make a table. Okay. I've provided space for both. Okay, then let's look at aerobic respiration. Now I want someone to go and write for us a balanced equation. Okay, one person to write a word equation for aerobic respiration and another one to write a balanced equation for the same. Which one do you want to write? Okay. Why do you choose to stretch when I'm looking for someone to send? Word equation for aerobic respiration. Did you do biology in high school? Yes, you should be able to try that out. When she gets stuck, you can help her. Word equation, and then someone should go after her to write the balanced symbol equation. Now we'll give you the raw materials and the products, okay? Yeah. Now can you give her the reactants? What are the reactants? Glucose, good. Is it that in this class people didn't do biology, or what is it? Are you hungry? Carbon dioxide is a product. We are writing word equation, my darling. Somebody will come to write the symbol equation. Don't include ATP, just write it as energy at the end. At the end. What? Your handwriting, Manze? Okay. Now someone else to go and write the balanced symbol equation for that. At least you know each of them how they look like. You don't have, yes, Clarice? Now before you proceed, because now if you proceed like that, you will be very stressed. C6H12O6. O6. Not O22. O6. Yeah, now go ahead and balance. Now in that equation, glucose is okay. Glucose is okay. Just add a 6 before oxygen. Yeah. So that's aerobic respiration. Now, aerobic respiration yields more energy than any other type of respiration. It yields more energy than any other, type of respiration. Now, aerobic respiration is controlled by enzymes. Are you seeing why enzymes are important? It's controlled by enzymes. And produces carbon dioxide and water as the only byproducts other than energy. Produces carbon dioxide and water as the only byproducts other than energy. Okay, now let's go to anaerobic respiration. Now, did you know that it is possible to respire without oxygen? Now, this process is also known as fermentation. It's also known as fermentation because it leads to the production of an alcohol called ethanol. Okay, so the only reactant here is glucose. All right, and we have two products, alcohol plus carbon dioxide plus energy. All right, so we know that glucose has 6 H12O6 to give us so this process is also known as what? Fermentation, because of the fact that it produces alcohol. Now this is in plants. So the above process happens in plants. The above process happens in plants. Now, group 4, please go for your health break. Huh? Group 4 have come. There is no resting. They are going without, like. Okay. Okay, group 1, you can go then. Now, please don't take a break of more than 1 hour. 20 minutes. Okay. Ah, okay. Now, when anaerobic respiration happens in animals, we get, or in humans rather, we get lactic acid plus energy. Now, please copy that. Copy that. Okay. Roman number 14. Now, about anaerobic respiration, you need to note that anaerobic respiration does not use oxygen, all right? And when it occurs in alcohol, it makes alcohol in yeast and plants and lactic acid in animals. So when it occurs in yeast and plants, it makes alcohol. And then when it occurs in animals, it makes lactic acid. Now, anaerobic respiration releases less energy from each molecule of glucose compared to aerobic. Anaerobic respiration produces much less energy from each molecule of glucose compared to aerobic respiration. Where is my book? That book keeps disappearing and appearing. Is it this one? Yeah, it's this one. Oh, it doesn't have. Okay, tab, yeah, calibri. Calibri. Now, the next thing I want us to discuss is the features of gas exchange surfaces in humans. Now, this morning we looked at the gill. You remember? How many were there when we were looking at the gill? Now, we looked at the gill and we were able to see typically how gas exchange surfaces look like. All right? Now, even basing on what we saw, without necessarily seeing a human's lungs or whatever, what do you think are the features of gas exchange surfaces in humans? Features of gas exchange surfaces in humans? Hey. Please raise your hand and give us an answer. Okay, number one, they are thin to allow gases to diffuse through them quickly. They are thin to allow gases to diffuse through them quickly, or to diffuse across them quickly. Now, when you look at the fourth point, good supply of oxygen, yeah, you can explain it by saying that they are close to an efficient transport system. They are close to an efficient transport system to take gases to and from the exchange surface. They are close to an efficient transport system, close to an efficient transport system to take gases to and from the exchange surface. To take gases to and from the exchange surface. Now the third point talks about large surface area. Now they have a large surface area so that a lot of gas can diffuse across at the same time. They have a large surface area so that a lot of gas can diffuse across at the same time. They have a good supply of oxygen. I've already talked about that. Okay. Now, excellent transport system, meaning that they are highly capillarized, meaning they have many blood vessels surrounding them. Excellent transport system means that they have many blood vessels surrounding them, for example, capillaries. So that's when we say they are highly capillarized. So that's still okay. And on the next page, we have the alveoli. The next page, we have the alveoli, which is the exchange surface in the lungs. The alveoli is the exchange surface in the lungs. So, alveoli are sac-like projections found in the lungs. Alveoli are sac-like projections found in the lungs that increase surface area for gaseous exchange. That increase surface area for gaseous exchange. that increase surface area for gaseous exchange. They possess all the features of gas exchange surfaces and are well adapted for the task. They possess all the features of gas exchange and are well adapted for the task. Okay, let's look at gas exchange in humans. And the first thing I've done is by reminding you that the process of gas exchange in humans is diffusion. Are we together? Yeah, the random movement of particles from a place of high concentration to a place of low concentration. This is purely by random movement. There is no help probably by protein carriers or by energy from respiration. It just happens. So that's a good thing. Now, the parts of the breathing system. Parts of the breathing system. Now, the diagram is there, very well labeled, but I've not written the purposes of each and every part of the breathing system. So I feel like we should just discuss what is important, or rather, not like some parts are not important, but we don't need to go into very many details. Are we together? Now, can we discuss several parts? Now, the ribs, for example. The ribs, this refers to the bone structure that protects the internal organs such as lungs. Bone structure that protects internal organs such as the lungs. Now, I know you can see intercostal muscles, and we have external and internal intercostal muscles, but I'll give the function as a combined function. Now, intercostal muscles are the muscles between the ribs which control their movement. You might write a lot between now and tomorrow, by the way. Let me just prepare you. Do you have energy for how many more hours? 20 more hours. Huh? You do? Yes. Okay. Because we have done a lot of practicals, isn't it? Yeah, so we need to cover a lot in theory as well so that we are able to achieve much. Okay? Yeah, so intercostal muscles are the muscles between the ribs which control their movement, causing inhalation and exhalation. Muscles between the ribs which control their movement, causing inhalation and exhalation.
Okay, let's look at the diaphragm. All the spellings are there in case you are not sure. Now the diaphragm is a sheet of connective tissue. The diaphragm is a sheet of connective tissue and muscle. The diagram is a sheet of connective tissue. Hey. Where? Maston ni wewe. Where? Sheet of connective tissue and muscle at the bottom of the thorax that helps change the volume at the bottom of the thorax that helps change the volume of the thorax to allow inhalation and exhalation. Trachea. This is the windpipe that connects the mouth and nose to the lungs. This is the windpipe that connects the mouth and the nose to the lungs. Larynx is the next one. Now the larynx is also known as the voice box. Wanaume oye. Also known as the voice box. And when air passes across here, we are able to make sounds. When air passes across here, we are able to make sounds. So, you are not writing this, but I just thought about it. If you get injured, your voice box, or you get an infection in your voice box, okay, then you cannot speak, you cannot make sounds. Marlon? Sometimes it's not the larynx, sometimes it's the brain. Are we together? Yeah, the part of the brain that develops the speech probably either is injured or did not develop as it should. So sometimes it could be the larynx that is underdeveloped, or sometimes it's the brain, sometimes it's a nervous problem. Okay? Yeah, so I mean, an investigation has to be done so that you know the cause. Yeah. Okay, you may find that probably they had a cancer of the throat, or a bad serious infection, or just a growth that is not necessarily a cancer. So the moment they cut, they put an an artificial device that acts as a voice box. But because if it is artificial, it can't produce the voice the way naturally it should. Yeah, so I saw one that they say that she has recovered from throat cancer. They have put for her a big, because they had to cut almost, they had to dig out this part, all these things. You see all this, they had to remove because they were saying it has cancer. Okay? So they inserted in her a device, an artificial device, and she's able to speak. It's just that her voice inatoka design flani, but yeah, she sounds like she's squeaking, but she speaks, imagine, and that thing is artificial. So
I think I've answered that. So which one are we looking at now? The bronchi. Bronchi are large tubes. Bronchi are large tubes branching off the trachea. Bronchi are large tubes branching off the trachea with one bronchus for each lung. Bronchioles. Now bronchioles are as a result of bronchi splitting to form smaller tubes. Are as a result of bronchioles, bronchi splitting to form smaller tubes called bronchioles in the lungs connected to the alveoli. Forms smaller tubes called bronchioles in the lungs connected to the alveoli. Then let me give you the last one. That's the alveoli. Alveoli are tiny air sacs. Group 2, go for your health break. Alveoli are tiny air sacs where gas exchange takes place. Alveoli are tiny air sacs where gas exchange takes place. Tiny air sacs where gas exchange takes place. Now, before we even go to the pathway to the lungs, I want us to look at the differences between inspired and expired air. Differences between inspired and expired air. So, let's draw this table. We draw the table of the composition of air. And yesterday when we were testing for carbon 4 oxide, we already saw that expired air has what? A higher percentage of carbon 4 oxide. So in terms of oxygen, inspired air has 21% and expired air has 16%. Now, carbon dioxide. Carbon dioxide has 0.04% inspired, okay? And then expired is 4%. Then we have nitrogen. Now we won't look at the others, okay? Nitrogen is 78% inspired, 78% expired. Now, in addition to this, it's important to note that expired air has much more water vapor than inspired air. Expired air has more water vapor. Than inspired air. exhaled water vapor is considered as a waste product. Exhaled water vapor is considered as exhaled water vapor is considered as a waste product. Considered as a waste product. So we already did this. We did this. Okay? I'm saying you've already done the investigations I'd wanted for today. Now, yesterday we investigated the effects of physical activity on breathing. You remember? I don't know, is that the next thing? No, pathway to the lungs, radar function. Okay. Let me get that book. Now let's look at the pathway to the lungs. Pathway to the lungs. Now, air enters the body through. Where does air enter the body through? Air. Huh? So just say nose. Sasa nostrils tena ni za nini? Scientists love overthinking. Isn't it just a nose? Okay, nostrils then. Now air enters the body through the nose or the mouth. Air enters the body through the nose or the mouth. Now, why is it better to breathe through the nose than through the mouth? Why is it? Umeongea sana haki. Lucy? Yeah, so you remember, I agree with you, and you also remember when we were looking at spatial cells, yeah? We talked about what? The ciliated epithelial cells, and then in addition to ciliated epithelial cells, we also have goblet cells. What's the work of the goblet cells? Huh? Secrete mucus. And what is the work of the mucus? Work of the mucus? Jelimo? Lubricant for what in the trachea? Huh? Okay. Yeah, so the work of the mucus is to trap dust, as Jelimo has said, and also to trap bacteria. And then the work of the cilia is to sweep the trapped mucus away from So let us note that And then another thing that the nose has is hairs. Did you mention hairs? Okay. The nose also has hairs that help trap dust particles. Now, I don't know if I gave you this diagram. Oh, yes, I did. Now, you can see the layer of the trachea in the body. Now, you can see the cilia and how the cilia beats the mucus away. Now, can you see that the same location of the cilia is the same location of goblet cells? Why? Why is it the same location? Yes? Because their functions are interrelated. Their functions are similar. They may not be the same, but they are similar. The aim is to make sure that there is no dust and there is no bacteria that gets to the lungs. Right? Anything anyone wants to add? Yes, Haron?
Another function of the mucus is to moisten the air.
As it gets into the lungs. Perfect. Haron says that another function of the mucus is to moisten the air as it gets into the lungs through the trachea. Trachea, bronchi, bronchioles, alveolus. Now, I'm coming, we discuss the trachea just now. the thorax by pulling the diaphragm downwards. Now, at the same time, the external intercostal muscles contract, pulling the rib cage upwards and outwards. At the same time, the external intercostal muscles contract, pulling the rib cage upward and outwards. Upward and outwards. This also increases the volume of the thorax. This also increases the volume of the thorax. 46.5 hours. You're doing well. Now let me explain something before we write it. Okay? Now we are saying that when we are breathing in, the muscles of the diaphragm contract and they pull the diaphragm down. Are we together? So this increases the volume inside the thorax. Are we together? Now at the same time we say that external intercostal muscles contract. External intercostal muscles contract, pulling the rib cage upward and outward. Are you seeing the movement of the rib cage? Upward and outward. Can you breathe in deep? Now if you put your hand here and you're breathing in deep, you will feel the rib cage going up and outward to increase the pressure in the thorax. And so that means that when to increase the volume, so when the volume increases, the pressure decreases. And now when the pressure is lower, okay, inside, what happens? The air that has a lot of pressure does what? Gushes into the body or rushes into the body. And that is how breathing in happens. Are you together? So let's write that. Increase in thoracic volume decreases thoracic pressure. Now thoracic is written as C-I-C. Thoracic. Thoracic. Okay? We've said that when thoracic volume increases, thoracic pressure decreases compared to the external atmospheric pressure. Enoch. Let's write notes. Thank you. Wow, he has even stood. The determination is real. Huh? Kama unajijua si usimame tu. Kwa nini unaningoja nikuite? Hey. Wow. Let's keep writing. So this causes air to rush into the thorax. This causes, oh yeah, actually they don't even know where we are. Please, help them. Now this causes now which statement did I say before I started with these causes?
Increase in thoracic volume decreases thoracic pressure, causing
causing air to rush in. causing air to rush in. One more night. Hey. One more night. A whole night. Now, I think other than now explaining to you in the way I've explained to you, now I've tried to remove unnecessary details for you, because I don't know if anyone here wants to go and study further about the breathing system. Are you together?
Yes.
Yeah, so I didn't see the need to start saying terminologies, and it's just showing you the understandable part of it. Are we together? Now let's look at how exhalation occurs, how expiration occurs, or how breathing out occurs. Group 3, raise your hand. Group 3. Haya, mnaweza dondoka briefly. My break is at 4:34. 4:34. Or 6 hours. Now, when you're breathing out, the muscles of the diaphragm relax. When you're breathing out, so go where there is the diagram for exhalation, okay? Yes. Now, when breathing out, the muscles of the diaphragm relax, making the diaphragm return to its dome shape. When breathing out, the muscles of the diaphragm relax, going back to its dome shape, full stop. Now this decreases the volume in the thorax and increases thoracic pressure. I repeat, this decreases the volume in the thorax and decreases the volume in the thorax and increases this decreases volume in Now, when the pressure increases in the thorax, it forces the air within the thorax out. So this increase in thoracic pressure forces the air out, or rather squeezes out extra air from the thorax. Squeezes out extra air from the thorax. All right. Now, who is very good at reading? Because there's a lot of reading here that I want to do for you. Like you read is like you're reading news until we understand. Okay. If you read quickly, you know. Okay, come. Yeah, and yeah, I think she'll need the mic. Are the mics there? I think we'll sort you out. So you're reading this, then this, and then this, and then this. I am just avoiding making people to write all this. Okay? Yeah. So here, then here, then here, then here. You audible enough?
I think so. Good afternoon. Good afternoon.
Good afternoon.
So the topic is exercise and breathing rate. Am I clear enough? Jenny Mo, can you hear me? All the cells in your body need oxygen for respiration, and all of this oxygen is supplied by the lungs. The oxygen is carried by the blood to every part of the body. Sometimes cells may need a lot of oxygen very quickly. Imagine you are running in a race. The muscles in your legs are raising a lot of energy. The cells in the muscles will be combining oxygen with glucose as fast as they can to release energy for the muscle contraction. I'm still audible? Okay. A lot of oxygen is needed to work as hard as this. You breathe deeper and faster to get more oxygen in your blood. Your heart beats faster to get the oxygen to the leg muscles as quickly as possible, but eventually a limit is reached. The heart and lungs cannot supply oxygen to the muscles any faster, but more energy is still needed for the race. How can that extra energy be found? Extra energy can be produced by anaerobic respiration. Some glucose is broken down without combining it with oxygen. So there's an equation of glucose then leading to lactic acid plus energy. As explained on page 141.
Page 141. Let me see what page 141 says. Okay, page 141 is basically talking about what respiration is, what aerobic respiration is, what anaerobic respiration is, and the differences between aerobic and anaerobic, okay? So whatever article she's reading here or whatever page she's reading here is referring to what we have already done, because that's the first thing we did when we started the topic, all right? Yeah, so I think you can continue.
When you stop running, you will have quite a lot of lactic acid in your muscles and your blood. This lactic acid must be broken down by combining it with oxygen, into bracket aerobic respiration, in the liver. So even though you do not need the energy anymore, you go on breathing faster and more deeply, and your heart rate continues to be high. You are taking in and transporting extra oxygen to break down the lactic acid. The faster heart rate also helps to transport lactic acid as quickly as possible from the muscles to the liver. While you are running, you build up an oxygen debt. You borrowed some extra energy without paying for it with oxygen. Now, as the lactic acid is combined with oxygen, you are paying off the debt. Not until all the lactic acid has been used up, there is a breathing rate. The rate of heartbeat return to normal. The rate at which your breathing muscles work, the rate at which your breathing muscles work, and therefore your breathing rate is controlled by the brain. The brain constantly monitors the pH of the blood that flows through it. If there is a lot of carbon dioxide or lactic acid in the blood, this causes the pH to fall. When the brain senses this, it sends nerve impulses to the diaphragm and the intercostal muscles, stimulating them to contract harder and more often. The result is a faster breathing rate and deeper breaths.
All right. Now, this is in relation to the exercise we did yesterday when I asked people to do jumping jacks for 3 minutes and they were unable to do for 3 minutes and ended up doing for 2 minutes. Then we measured the differences in what? In number of breaths per minute. Are we together? Yeah, so basically, I said yesterday that your body requires a certain amount of oxygen at rest, but the moment you start exercising, the demand for oxygen increases. Demand for oxygen increases, and your body has to find a way of managing that. So that is when anaerobic respiration kicks in. Now, have you ever done exercise and the next day your legs were aching? What do you think happened? Yes? What do you think happened? Tearing of muscles? Oh yeah? No? Hey, tearing would be very painful, let me tell you. Huh? Like now mine are aching, by the way. It's good for me to say that. Yes? Contraction and relaxation of muscles causes the pain? Yes. It's lactic acid. Okay? Accumulation of lactic acid in the muscles. So that lactic acid is not a friendly substance to the muscles. Are we together? Yes. So you have to pay off that debt that was given to you by the anaerobic respiration. And so, when oxygen now oxidizes the lactic acid, when oxygen oxidizes the lactic acid now to give you energy and to release carbon dioxide and water, the muscles heal because there is no more lactic acid, okay? So that is what she was trying to read. And that is what made us to do that exercise that we did yesterday. So, so based on what she has read and what I have explained, I'd like you to write a short explanation, a short explanation as to why the number of breaths per minute increases when you do exercise for 3 minutes and further increases when you do exercise in 6 minutes. So write just 2 or 3 sentences. And then we already did uses of energy in living organisms. It was the first thing I did when I introduced respiration, isn't it? Yeah, so you can say refer to 1.79. Yeah, refer to 1.79 for uses of energy. And then now, give me the explanation for increase in number of breaths per minute. Is there anyone who was not there when we were doing that exercise? We were all in class? Okay. That's interesting.
said he'll print for us. He said he'll print for us. Yes. Will they print for us? Yeah. So, what exact time did we start? What exact time did we start on Tuesday? I think it was 4:50. Yes. So tomorrow, when we get to 66 hours, is when we will give out this exam. So that isikuwe time ya exam haitahesabiwa. We'll extend. I'm thinking. Na wakinikata hizo 2 hours. Hawajui.
We are done now. Now, we have a problem there. And you know problems are normally yours. I mean problems in the paper. Are we together?
Yes.
Okay. Okay. Let's do the problem together. The graph shows, am I on? The graph shows how a student's breathing rate changed during and after exercise. All right? Now, time in minutes. So exercise starts at, I think, 1 minute and ends at 11 minutes. So how long did the student exercise? 10. Calculate the increase in student's breathing rate from when he started to exercise. From when he started to exercise to its maximum rate. So when he started to exercise, he was at around, is that 12.5?
Yes.
Or 13?
13.
Which one should we work with?
13.
13, eh? And then the maximum is 24. Yeah? No. Jafika 25. It's 24. Oh, it's 25. Hey, you guys are sharp, eh? My eyes were seeing 24. You know, you guys have been sleeping. Me. Anyway. So, increase. Increase is, yes. We are subtracting 25 minus 13. So we have increased by 12 breaths per minute. Now, how long did it take after he finished exercising for his breathing rate to return to normal? So 11 minutes minus 16 minus 11 minutes. How many minutes is that? 5 minutes. Now, do you know why those questions are having 2 marks? Because you have to show on the graph how you're getting these answers. They have to see those vertical and horizontal lines as you're trying to derive your answers from there. As you're trying to derive your answers from the graph. Now, see. Explain why his breathing rate did not return to normal immediately after exercise stops. 4 marks. Hey, what do we write until we get 4 marks? Huh? Why is it that his breathing rate did not return to normal immediately he stopped exercising? Yes? I want to hear your views. Let us get the 4 marks together. Yes, Alvin? A lot of heat. Fast breathing cools the body. Huh? Well, I know it cools the body of animals. I didn't know about humans. Where? Can we refer to something else that we are sure about? Yes, Jelimo?
Too much lactic acid may matter so the muscle return, too much breathing, so that the person could
Yeah, so she's saying that both aerobic and anaerobic respiration took place, right? And so after exercising, we needed to pay off the oxygen debt and eliminate what? The lactic acid that had accumulated. And after that the breaths went back to being normal. Okay? And do you know another reason? Okay? Is because the rate of breathing had increased. So it needed time to come down to the normal numbers and the normal rate. Now, I like question D because question D is is trying now to make us think how also
the heart rate is going to increase, and why? How also the heart rate is going to increase, and why? Now, in the exercise that we did 2 exercises. One exercise was measuring the difference in heart rate or heartbeats per minute, and then we did another one that was talking about the number of breaths per minute. Now, for 4 marks, describe and explain how you would expect the student's heart rate to change during the 16-minute period shown on the graph. So you have to account for every time, like before, mentioning figures and specific breaths per minute as the exercises started increasing after the exercise and up to the time. Is it a she or a he? He went back to the normal breaths per minute. So I want to hear your answers in 2 minutes. Group 4, go for you. But there's a group that is out. Okay, as I go around checking your answers, I want you to finalize on your heart models for display now. I'm marking part D. Close this. It's going to dry. If you're done with part D, raise your hand. I come and mark for you. Now, if you want, you can refer to the explanation we gave yesterday after we did the exercise on change in heartbeats per minute before and after exercise. I remember we did some explanation there. And then entry of oxygen debt to eliminate the lactic acid. This is C. Okay. Now, you need to mention where does the lactic acid come from, okay? And why is there need for anaerobic respiration, okay? Okay. So you've lost 1 mark. You've lost 1 mark. Where's my lab coat? Where's my lab coat? Niliweka wapi lab coat yangu? Where's my lab coat? What's in my lab coat? Thank you. Keep writing. Are we stranded? No, it was after all this. We did it at... Unless you did not write the explanation. It's 1.64. Average increase of heart rate per minute increases after exercise. You didn't give the explanation. You know what we are doing? Explain the effect of physical activity on the heart rate. You were not there when we were doing this. And when you came, you didn't catch up. Now, are you seeing why I have been saying that when you go for break, you come back and catch up with what others have done? Get a peer to assist you with that one. I won't repeat. Yes, let me help. Now, Alvin, after exercise, according to you, the heart rate would have decreased in comparison to the 11th minute, as the heart would be pumping blood at lower pressure due to decrease in the activities being done. Now the question is asking, describe and explain how you would expect the student's heart rate to change during the 16-minute period shown on the graph. So you are supposed to account from zero, say what happens between 0 to 1, what happens between 1 up to the time it goes to its peak, and then when it starts decreasing, and then when it goes down back to where it was. So you have not answered the question. You have made your own question and answered it. Are you done? Let me see. This is now, Alvin, I also saw a statement. You said that muscles make lactic acid. Have you said such a statement? No, muscles do not release lactic acid. Lactic acid comes as a result of anaerobic respiration, and then it accumulates in the muscles. But it's not the muscles muscles do not have any mechanism of releasing lactic acid, okay?
I like your answer for D. At least you've been able to capture everything. Yes. Group 4. All the others are back. Group 4 members, raise your hand. Group 4, you can go for your health break. There are more models behind. Asante.
Sukuma. We're hoping maybe for your break, number one break at 4:30.
Yes.
So 1 minute too. Just get to hear how you're feeling. Okay. Is there a restriction to that?
No.
Okay.
None.
You're very composed. Composed that una pressure. Ni mambo na target 66.
66.
Target 66 hours.
Yes.
Okay. Kukaa 3 hours peke yake za kubreak kwanza hata usikushtue. Hiyo ushavunja.
Carry it nicely and display it somewhere. Give it to me. And this as well. Now, whose book haven't I seen? Anybody's work I haven't seen? So you needed to talk about the heart pumping faster and the breathing becoming deeper, faster and deeper. Yeah. I think we'll move on to the next topic. Yeah, we'll move on to the next topic where we are defining oxygen debt and explaining how lactic acid builds up in muscles. I think we have already done that. So we can move on to diseases and immunity. So in your own free time, you look at defining oxygen debt and explaining how lactic acid builds up in muscles and blood during vigorous exercises. So now we can go to 1.81, diseases and immunity. And I'd first like to ask you, what is a pathogen?
and what is its role in the body. Pathogen. Lenny, tell us what a pathogen is. Sorry? Exactly that. So pathogens are organisms that cause diseases, and I'm sure you have examples of pathogens. Or rather, you know examples of pathogens. Can you write one pathogen that you know and the disease it causes? And then we'll go around sharing and listening to what you are able to come up with. So a pathogen is a disease-causing organism, okay? And pathogens are passed on from one host to another through diseases that are transmissible diseases. Entail transferring pathogens from one host to another. So now after you write that, you give us an example of a pathogen and the disease it causes.
Virus, Vibrio cholerae.
Is Vibrio cholerae a virus?
No, the pathogen is
No. Vibrio cholerae is a bacteria.
pathogens is the general term.
For all disease-causing organisms.
So normally is Vibrio because
Okay, let me hear the pathogens you know and the diseases they cause. Yes, Marlon.
Salmonella typhi.
Salmonella typhi,
Typhoid.
causes typhoid. Did you know about that one before yesterday? So that one I'm the one who gave you. Look, write yours now.
Vibrio cholerae.
But I also gave you that one. Yes.
the female mosquito, they have the plasmodium that causes
The female was?
mosquito. They have the plasmodium that causes the malaria. That also can be a pathogen.
Plasmodium is a pathogen. It is in the kingdom Protocotists, but it is hosted by the female Anopheles mosquito. Yeah. So without the female Anopheles mosquito, by itself, it cannot cause diseases. That's why all together, they say that it is the mosquito that causes, because it's the mosquito that enables the plasmodium to cause diseases. Yes. Okay, I think now we can share the pathogens we know and the diseases they cause. At least everyone should be able to share one. Yes, Marlon? Sorry?
I'm trying this one. I don't think I remember it well. Streptococcus pneumoniae causes pneumonia.
Yes. Streptococcus pneumonia causes pneumonia. Is that what you are writing? Oh, yeah. Look for another one. Plasmodium malariae causes malaria. So look for another one.
Bordetella pertussis.
Bordetella pertussis causes
Whooping cough.
whooping cough. I didn't even know that one. Thank you for teaching me. Yeah, I didn't know. Sorry? Bordetella pertussis. Oh, wow. Haron, give us a pathogen you know and a disease it causes. Fly causes what? Okay. Yes. Good. Brian, give us a pathogen you know and the disease it causes. Huh? Yes, fungi causing athlete's foot. There are even two that I gave people yesterday, but I can't see anyone mentioning them. No, but wenye sijawaambia wasiweke. Damaris, Zama, give us a pathogen you know and a disease it causes. Vibrio cholerae causes cholera. Diana. No one is even saying COVID-19 virus.
COVID-19 virus, coronavirus.
Okay. COVID-19 disease. Yes? Huh? HIV ishasemwa. Anyway, let's move forward. Let's proceed. Now, the next thing we are going to look at is how pathogens enter the body. How pathogens enter the body. Now, there are several ways that pathogens enter the body, and these ways are called mode of transmission. All right? Now, the first one is droplets in air. Droplets in air, like when somebody coughs without covering their mouth, or when somebody cries and their tears get into your hands or wherever. I mean, any droplets that are in the air, mucus, saliva, all those things. Those are methods in which pathogens can enter the body. And diseases that are spread through this way are common cold, influenza, coronavirus disease, tuberculosis, okay? Meningitis? No, meningitis is not transmissible through air droplets. Oh. HIV is caused through other droplets, not droplets in air. Okay? Okay, now another method of transmission is food or water. And diseases that are caused by, or rather transmitted through food or water are cholera, typhoid, and dysentery or dysentery, depending on who your first teacher was. Mine said dysentery. Then I heard people saying dysentery. So, I'm saying both so that you choose. Okay, the third method of transmission is by touching contaminated surfaces. And ingesting food without washing hands. For example, typhoid. Typhoid is caused by a bacteria called Salmonella typhi that thrives very well in feces. Okay, fecal matter. I'm sorry for using that word. Fecal matter. Now, how does fecal matter go back into your digestive system until it causes typhoid? Yes?
Let's say someone took a dump in a river,
Uh-huh.
then you walked by and the water splashed and got into you through your clothes.
Uh-huh.
And you might contract it.
No, Salmonella typhi attacks the alimentary canal first. Alimentary canal. Typhoid is not through the skin. Okay? Uh-huh.
Maybe the river,
Mm-hmm.
you use the water for cooking something, and or
Mm-hmm.
you drink the
Or you drink it, yeah? Or you go to the washroom and you don't wash your hands. Then you ingest food with your hands. Then you're ingesting what? The bacteria. Okay? Now, another substance, or not substance, another organism that can cause diseases by contact are houseflies. Now, houseflies like fecal matter, especially moist fecal matter. Are we together? So that's why you rarely find houseflies on fecal matter of animals that release hard fecal matter, okay? So when they come from the fecal matter and they come on your food and you chase them like this, then you continue eating, okay? Yeah? Or they get on your in your drink and then you say silipi ingine. Eh? Unaitisha kijiko, unaitoa, unatupa. So they leave you with Salmonella typhi. Are we together? Now the fourth method of transmission is insect bites. Through insect bites. Now, we have a plasmodium that causes malaria, and this plasmodium cannot survive without being in a host. Now, the host that this plasmodium has chosen is the female Anopheles mosquito. I don't know what the female Anopheles mosquito gave this plasmodium, because it cannot thrive in another type of mosquito. That's why Nairobi mosquitoes keep biting us, but we don't get what? Malaria. But if you go to Kisumu, where else? Generally the western region where the female Anopheles mosquito thrives, you come back with malaria, okay? So without the female Anopheles mosquito, the plasmodium is unable to transmit a disease. And that's why all together we say that mosquitoes cause what? Malaria, which is not true. Now you know. Mosquitoes carry the pathogen, and then the pathogen use the mosquito as the host. Are we together? Yeah, so through insect bites you can get diseases like malaria, dengue fever, sleeping sickness, okay, elephantiasis, that come as a result of tsetse or rather bites from tsetse flies. So after that we look at, yes?
You had mentioned something about diseases that penetrate through your skin.
Diseases that penetrate through
Bilharzia.
bilharzia. Now that still comes as a result of not really biting, okay, but the disease causing pathogen getting into your body through your skin, okay? Because for insect bites, the organism will bite you and leave. Okay, but for bilharzia, for there's another one, athlete's foot, that is caused by fungi. The organism attaches itself on the skin and then gradually gets into the body and hosts there and lives there and reproduces there until you do something about it. Yes? Now, chickenpox is caused by a virus, and that's why up to date, it does not have a cure, all right? But at least nowadays there is a vaccine for chickenpox, okay? So with time, the strain for that virus has become weaker. It used to be so prevalent some years ago, okay? But now I think we are almost overcoming it, because I hear there are people who even become adults without vaccinating themselves and they don't get the chickenpox. Okay. Have you been vaccinated against? And have you ever gotten it? Okay. You need to keep... just keep praying. Don't... Si bado unaishi. So just pray. Okay. Now let's look at... now, indirect transmission basically is as a result of hosts. Are we together? Yes. Hosts. And there you can give an example of the female Anopheles mosquito hosting the Plasmodium. So after that, we can look at the body's defense mechanisms. Now, how do you think the body protects itself from diseases? How does the body protect itself from diseases or against diseases? Yes, Omala.
We have the skin,
Mm-hmm.
preventing germs such as
Yeah, so there are three main ways in which the body defends itself. And the first one is through mechanical barriers. And he has given an example of what? Of the skin. So when the skin is cut or rather injured, it immediately begins to heal itself, forming a scab and preventing pathogens from getting into the body. So can you give me other examples of mechanical barriers? We are in number 1, mechanical barriers, and we have given an example of the skin. Then I need another mechanical barrier that prevents or protects humans against diseases. Cynthia? No, vaccination falls. Actually, it falls under cells because a vaccine is an inactive form of the pathogen. Okay? Now, we talked about the trachea and the ciliated epithelial cells and how the goblet cells produce mucus, trapping bacteria and dust. And then what does the cilia do? It sweeps away that mucus that has trapped bacteria and dust away from the lungs. Don't you think that is a physical barrier, like the hairs in the nose that now help to trap the bacteria and the dust? That's a mechanical barrier, isn't it? Yes, so we can say the hairs in the nose make it difficult for pathogens to get past them. Hairs in the nose make it difficult for pathogens to get past them. Further up the nose, so they are not inhaled into the lungs. further up the nose so that they are not inhaled into the lungs. Okay, as I said earlier, the body has 3 ways of defending itself against diseases. So the second way is through chemical barriers. And chemical barriers basically refers to substances that are produced to either trap or kill the pathogens. Chemical barriers refers to substances produced by the body to either trap or kill pathogens before they can get further into the body and cause diseases. Before they can get further into the body and cause diseases. So, based on that definition, give me examples of secretions that happen in the body that stop pathogens from going further into the body and causing diseases. Yes, Clarice? Sorry? You've forgotten? Sorry. Yes, Cynthia? Mm-hmm. Yes. The first one is stomach acid, as she has said. That is a strong acid that kills bacteria and prevents us from getting infections in the alimentary canal. Mm-hmm. Another secretion that is made in the body, mucus. Now, which cells produce mucus? Goblet cells produce mucus along the trachea. Goblet cells produce mucus along the trachea. And the mucus traps bacteria and dust. The mucus traps bacteria and dust. Sweat is an excretory substance. It's not a secretion that can stop a pathogen from getting into the, or from going further into the body and causing diseases. Yes, Fabian?
How about
Sneezing?
sneezing?
Sneezing is a reflex action. Actually, sneezing is a nervous response. Okay? It's a reflex action, a nervous response for when it doesn't have necessarily to be something harmful. Have you ever taken chewing gum that has menthol and you sneeze and sneeze and sneeze? Yet whatever you're taking is not really harmful. Yeah. We'll buy for you menthol so that you sneeze. So we have talked about mucus and stomach acid. Omala, not Omala, Marlon. No, we are not yet there. We are still talking about chemical barriers. Now, antibodies are not chemical barriers, okay? Now, the third way through which the body defends itself against diseases is through cells. So tell us what you wanted to say about antibodies.
They produce platelets, which, I mean what cells.
Sorry, start again.
They produce the platelets.
The platelets?
And the white blood cells.
Uh-huh.
That protect the body against diseases or injuries.
I agree with your answer, but you contradicted yourself when you started with platelets. Now, platelets do not produce antibodies. Antibodies are produced by white blood cells, okay? So, the third
main way is by cells, okay? And the first type of cells that we talk about that defend us from diseases are the white blood cells. Now, white blood cells defend us from diseases by a process called phagocytosis. Phagocytosis, which is engulfing and digesting pathogenic cells. So there are types of white blood cells that are called phagocytes, okay? So when phagocytes detect that a certain cell is a foreign cell, they go to where the cell is and they elongate themselves, they engulf the pathogen, and then they produce enzymes that digest the enzyme and digest the pathogen and destroy the pathogen. So that is one way of defending the body against diseases by cells. Now the second one is by producing antibodies. Now antibodies work in two different ways. Okay? Now the first way is by snitching on the pathogen. Yes? Snitching. I'm saying that so that you don't forget. So you know what antibodies do? When they realize that this is a pathogen, they go and attach themselves to the pathogen. Okay? It's like somebody knowing you're a thief and then they go and type something saying, this is a thief, and then they come and stick it on you. Yeah, so that's what antibodies do. When they realize that this is a pathogen, they attach themselves to the pathogen so that when phagocytosis are circulating around the body, they will go attacking all the cells that antibodies have attached themselves to. Are we together? Yes, that's what happens. So that's why I'm saying that one way that they defend the body against diseases is by snitching on the pathogen to the phagocyte. Okay? Now the second way is by directly destroying the pathogen. So sometimes they can attach themselves and other times they can destroy the pathogen directly. Now, there are other ways that you can describe in your own words that if we are to follow the correct policies, okay, we would prevent so many diseases. Like, for example, policies on food hygiene, personal hygiene, waste disposal, and sewage treatment. So there are very many diseases that are caused as a result of unhygienic preparation of food. All right? There are many diseases that we get as a result of poor personal hygiene. Others come as a result of bad waste disposal. And lastly, lack of a clear way of sewage treatment and disposal. Are we together? So in your own words, as I take my break, just two sentences. Describe how you would prevent diseases by improving on food hygiene, personal hygiene, waste disposal, and sewage treatment. We'll discuss it after I'm back.
CPF is a financial services company that offers a whole host of solutions to the Kenyan public and across the globe. We have been recognized both locally and internationally as a trusted brand. And the following are some of the reasons why you should be working with us. Currently, we provide fund administration services to the largest schemes in the country. One of them is Lab Trust, which is the oldest. Having been established in 1929, it currently has a fund value of about 30 billion Kenya shillings and membership of about 20,000 members. The County Pension Fund, which is also one of the largest in the county space, and the Public Service Superannuation Scheme. Overall, we have total assets under management of over 100 billion. One of the biggest challenges in the social security sector has always been enabling people to save towards their retirement. And one of the solutions that we have also developed internally as CPF is called education.
with as low as 50 shillings every day or 500 per month to be able to take care of themselves at the point of retirement. At corporate level, we have solutions where we carry out fund administration for corporates that have already existing schemes, or they can be able to join our umbrella DC schemes within this called Taifa. We also do gratuity administration to assist corporates be able to administer the gratuity plans for their different staff within the organization. We also have solutions for chamas where we can be able to open up opportunities for them to be able to save and invest as chamas and also enjoy welfare solutions which are always covered under our trust fund called the Momba Trust Fund. As part of our solutions, under the management and training arm, we also do management consulting. Under management consulting, we consult for you to do governance audits, we do strategy development, among other consulting services that you might request. We also do trainings. Under trainings, we have trainings that are bespoke to the organization, or they can already be able to come in at best prices to attend some of the trainings that have already been packaged by the CPF arm. For more information, visit our website on www.cpf.or.ke, or you can be able to access the information on the CPF app on the Play Store or the iOS Store.
Hayo bwana, asante kutupeleka holiday bwana. Lakini na swali, uliniambia tuna save na CPF. Kwani ukisave unapata pesa wapi?
Boni, unajua first una save, halafu una spend. Nilikuwa nishaweka kitu CPF kabla sherehe.
Oh, okay. Na kama sina kitu this month nafanyaje?
Usistress. Ukiwa na CPF unaweza convert Safaricom Bonga points zinakuwa contribution yako kwa M-Pension. Na ni rahisi sana. Dial *289# au piga 011
or they can be able to join our umbrella
Hello,
to see
my name is
schemes.
Patricia Masivo and I'm a student at
We
the
also do
my undergrad and next to my
I
pursued my bachelor's.
Hello, my name is Favan Andrew. I'm a fourth-year student here at the University of Agriculture and Technology. I'm pursuing a degree in horticulture, and this is my final semester. So I lost my dad in 2018 when I was first year, second semester, and it was 1 week illness. After his death, my life was kind of difficult. I didn't know if I was going to continue with my studies.
We also do trainings,
My
and
mom
at
is
trainings
a
we have
housewife.
trainings that are bespoke to the organization, or they can already be able to come in at best prices
I must say it's thanks
to attend some of the trainings that are already being packaged by the CPF. For more information, visit our website on www.cpf.or.ke, or you can be able to access the information on the CPF app on the Play Store or the iOS Store.
I was not only taught to become a chemistry student, but also to become an all-round disciplined student, where I was able to bring in solutions for our modern world challenges. This is why
join us today.
In an uncertain world, trust is everything. Introducing Tamka Security Services Limited, your trusted partner in security solutions. At Tamka Security Services Limited, we understand that security is not just about protection, it's about peace of mind. That's why we specialize in providing comprehensive security solutions for homes, residential areas, and malls. Our team of highly trained security guards equipped with state-of-the-art technology ensure round-the-clock surveillance and protection. From guard services to K9 units, from installing electrical fences to providing quick response in times of emergencies, we also offer bodyguards and event security. Tamka Security Services Limited is your one-stop solution for all your security needs. With our commitment to excellence and swift action, you can rest assured that your safety is our top priority. Choose Tamka Security Services Limited for security you can trust. We are located at Rimpa along Magadi Road, and you can contact us on 0202 595098. Tamka Security Services Limited, protecting what matters the most.
His Excellency Mike Mbuvi Sonko, the Good Deeds Ambassador, crowned for his generosity in helping the needy. Sonko's move to help the needy is his way of life and started way before he joined politics. Hundreds of needy people from all walks of life can attest to this. Mariam Abdallah has been in and out of hospital, but Governor Sonko has always been there for the family.
Namshukuru sana mheshimiwa, yeye na familia yake, anawaombea sana kila nikiswali Mwenyezi Mungu awajalie kila la kheri. Natoa shukrani zangu kwa mheshimiwa Sonko kwanza. Mwenyezi Mungu amjaze kila la kheri. Amuondoshe matatizo yake, mazito amfanye mepesi. Familia yake Mwenyezi Mungu aijalie salama. Amenifariji mimi na amenisaidia mtoto wangu. Sikupata usaidizi wowote Mombasa zaidi ya kwamba ni hao katika wale wataja. Hamna mheshimiwa yote alikuja kunisaidia. Lakini nasema Mwenyezi Mungu yuko pamoja na yeye. Tumekuja naye kanikarimu vizuri. Alhamdulillah, na ubaguzi. Ni mwanamume ambaye sijui niseme nani. Anifadhili kwa kila kitu.
Tunakwambia rudi after 2 months, lakini umetupatia karatasi ile kule Mombasa. Unajua umeshona na chuma ile kutumia. So watamtoa.
Umeshakatia ndege
kila kitu waziri alipasha shughuli.
Sawa. Kidogo ya dawa na supu damu ile. Haya, shika ndio kununua naye dawa. Sawa.
Kwa majina naitwa Mariam Abdallah Kombo kutoka Mombasa. Nimeshukuru sana kusaidiwa na mheshimiwa. Operesheni zile zangu za kwanza alinisaidia nikafanyiwa, na hizi za pili tukarudi tena pia amenisaidia yeye. Namuombea Mungu sana yeye na familia yake. Mwenyezi Mungu ampe afya, ampe umri, ampe nguvu na amlinde na azidi kuwa na imani ya kusaidia.
Not once or twice has Governor Sonko intervened when the elderly are being neglected by the community.
Wewe nani mheshimiwa?
Hapana,
hapana, wewe kuja mama. Wacha kufanya hivyo.
Hapana, mama, wacha mama ingia ndani yako. Hapana, hapana. Hapana, haiwezekani.
Twende mami sasa ile
hapana
hapa.
Nimembariki nimempa baraka na mbariki zaidi. Apande juu. Amen. Ile yote tutaweza. Ubarikiwe na Mungu. Tusikutane nangu. Asante. Asante sana. Baraka kwa.
Hakuna mtu atakutoa hapa. Sasa uko na tunashukuru naye.
Times society neglects elderly people. A 100-year-old granny in Embo was forced to spend nights in jail for contempt of court, unable to pay a fine of 100,000. Sonko came to her rescue. Same story for a 106-year-old granny who was evicted from her land in Pangani, but Sonko helped her get it back. Several other people have also gotten back their grabbed land through the help of Governor Sonko.
Itakuwa registered kwa hiyo title yako na utarudishiwa hii shamba. Shamba yako itarudishwa kwa sababu tuna register hii imetoka kotini. Kwa hivyo itarudisha hiyo shamba kwako sasa. Yes. Please. Hiyo tutafanya mara moja na itarudi.
What I have to say is that today I have managed to have access to Mheshimiwa, which not many people can have. I think it was God's grace that maybe our dad had done something very good for us for today Mheshimiwa to be standing here and assisting me, because we just seen Mheshimiwa in the papers, we hear about him, but today I've seen it with my own eyes what work he does.
He has such a compassionate heart.
Ninaguzwa sana na moyo wake wa huruma.
You know there is politics.
Kuna siasa.
And there is a core.
Na kuna mwito.
This man is not a politician.
Huyu si mwanasiasa.
When I watch the way he handles the poor people,
ninapoona jinsi anawashughulikia watu maskini,
then I know
basi najua
there is something extraordinary in his life.
Kuna kitu kisicho cha kawaida ndani yake.
Governor Mike Sonko, through Sonko Rescue Team, has continued with his charity work, which he began even before joining politics. Meet baby Kyla, a 1.5-year-old baby. Governor Sonko met Kyla's mother in Westlands, who narrated her daughter's woes to the governor. Sonko was touched by the story of young Kyla, who had lost her eyesight at a tender age and vowed to help her seek medical attention in India. Weeks later, she is back after the surgery. Kyla was received by Nairobi County First Lady after landing at JKIA.
Wow, as you can see, God is good. This is a miracle. Baby Kyla, God bless you. Wow.
Since the day she was born, I noticed that she had some problems with her eyes. And I came to meet Sonko, and I told him about my story, and he decided to help me.
Beautiful baby Skendi Chelangat, whose life was threatened by a cancerous tumor in her eye. Sonko took the initiative to pay for her medical attention in India. She is now a happy child in school. It is a story of joy.
Happy today, so thank you Sonko for everything you've given me. May God bless you. Thank you very much.
Late March 2019, Governor Sonko donated tons of relief food to the drought-stricken counties of Turkana and West Pokot. The governor traveled by road to Turkana, where he distributed the assorted foodstuffs and set a medical camp for the needy.
He has brought a lot of food. We have gotten maize meal, vegetables, fruits, water. He brought bowsers full of water, rice, sugar, all different types of food. We want to also appreciate the quality of food because people who are hungry and weak are not able to chew hard food like maize. And so the maize meal that he has brought and other softer foods are going to be of help to these people.
Ningependa kutoa shukrani yangu kubwa zaidi pamoja na viongozi wengine wa Aloima na Turkana County na watu wa Aloima kwa jumla. Tunataka kutoa shukrani yetu kwa Sonko, Mike Sonko, Mbufi. Tunataka kumshukuru zaidi kwa sababu ya mazuri ambayo ametutendea.
Welcome to Heaven Trinity Motors, your premier destination for quality cars and exceptional service. At Heaven Trinity Motors, we bring you a heavenly experience in the world of vehicles. Discover a world of possibilities with our range of fresh import used cars. Each vehicle meticulously inspected and handpicked to ensure you drive away with confidence. Whether you are looking to upgrade, trade in, or sell on behalf, Heaven Trinity Motors is your trusted partner. We offer competitive rates for your trade-ins and ensure a hassle-free process when you choose to sell with us. Explore convenient bank financing options tailored to suit your needs, making your dream car more accessible than ever. Call us today on +254 707 073 551. Heaven Trinity Motors. Your journey starts here.
Introducing Champion Security, where protection meets peace of mind. In an ever-changing world, security is paramount, and we're here to ensure your safety with unmatched expertise and cutting-edge technology. Whether it's securing your home, business, or event, our team of dedicated professionals is committed to deliver top-notch solutions tailored to your specific need. With 24/7 monitoring and rapid response capabilities, you can trust us to be vigilant guardians. Don't leave your security to chance. Choose Champion Security and take the first step towards a safer tomorrow. Contact us now to learn more about our comprehensive security service and join countless satisfied clients who have made the smart choice for their protection needs.
In an uncertain world, trust is everything. Introducing Tamka Security Services Limited, your trusted partner in security solutions. At Tamka Security Services Limited, we understand that security is not just about protection, it's about peace of mind. That's why we specialize in providing comprehensive security solutions for homes, residential areas, and malls. Our team of highly trained security guards equipped with state-of-the-art technology ensure round-the-clock surveillance and protection. From guard services to K9 units, from installing electrical fences to providing quick response in times of emergencies, we also offer bodyguards and event security. Tamka Security Services Limited is your one-stop solution for all your security needs. With our commitment to excellence and swift action, you can rest assured that your safety is our top priority. Choose Tamka Security Services Limited for security you can trust. We are located at Rimpa along Magadi Road, and you can contact us on 0202 595098. Tamka Security Services Limited, protecting what matters the most.
CPF is a financial services company that offers a whole host of solutions to the Kenyan public and across the globe. We have been recognized both locally and internationally as a trusted brand, and the following are some of the reasons why you should be working with us. Currently, we provide fund administration services to the largest schemes in the country. One of them is Lab Trust, which is the oldest. Having been established in 1929, it currently has a fund value of 30 billion Kenya shillings and membership of about 20,000 members. The County Pension Fund, which is also one of the largest in the county space, and the Public Service Superannuation Scheme. Overall, we have total assets under management of 100 billion. One of the biggest challenges in the social security sector has always been enabling people save towards their retirement. And one of the solutions that we have developed internally as CPF is called Rukisha. Rukisha is a concept that we developed primarily to address people in the informal sector, people with small businesses, people with big businesses as well. And the intention is to help them save towards their retirement. We have incorporated a concept called Save As You Spend into the platform, where for every transaction you make, you're able to save a percentage of it. And over time, you're able to see your retirement funds accrue. One of the other benefits of utilizing Rukisha is you also have access to other solutions within the CPF group of products, among them being investments through the CPF asset managers. You should be able to save towards a specific goal under the CPF asset managers. You should also have access to the CPF insurance products under the laser insurance brokerage services, as well as the real estate products within the laser property management services. For more information on Rukisha, visit www.rukisha.com. You can also access it through the short code *391# or download it in the Google Play Store as the Rukisha app. Talk to us, reach out to us, and we shall help you achieve your retirement goals.
At CPF Financial Services, we've been able to package the solution for both for the individual, for the corporate, and also for groups. At the individual level, we've come up with products that are able to take care of the member both at before retirement and after retirement. For before retirement, we have training for the member to be able to prepare themselves to go out there and be able to save for themselves. Also at that particular level, they can be able to save individually on a continuous basis with as low as 50 shillings every day or 500 per month to be able to take care of themselves at the point of retirement. At corporate level, we have solutions where we carry out fund administration for corporates that have already existing schemes, or they can be able to join our umbrella DC schemes within this called Taifa. We also do gratuity administration to assist corporates be able to administer the gratuity plans for their different staff within the organization. We also have solutions for chamas where we can be able to open up opportunities for them to be able to save and invest as chamas and also enjoy welfare solutions which are always covered under our trust fund called the Momba Trust Fund. As part of our solutions under the management and training arm, we also do management consulting. Under management consulting, we consult for you to do governance audits, we do strategy development, among other consulting services that you might request. We also do trainings. Under trainings, we have trainings that are bespoke to the organization, or they can already be able to come in at best prices to attend some of the trainings that have already been packaged by the CPF arm. For more information, visit our website on www.cpf.or.ke, or you can be able to access the information on the CPF app on the Play Store or the iOS Store.
Prayo bwana, asante kutupeleka holiday bwana. Lakini na swali, uliniambia tunasave na CPF. Kwani ukisave unapata pesa wapi?
Boni, unajua first una save, halafu una spend. Nilikuwa nishaweka kitu CPF kabla sherehe.
Oh, okay. Na kama sina kitu this month nafanyaje?
Usistress. Ukiwa na CPF, unaweza convert Safaricom Bonga Points zinakuwa contribution yako kwa M-Pension. Na ni rahisi sana. Dial *289# au piga 0111 114 000 na CPF watakusort.
Hello, my name is Faith Wanjiru Kinyanjui. I'm a 4th year student here at Jomo Kenyatta University of Agriculture and Technology. I'm pursuing a degree in horticulture, and this is my final semester. So I lost my dad in 2018 when I was in first year, second semester, and it was a 1-week illness. After his death, my life was kind of difficult because I didn't know if I was going to continue with my studies because my mom is a housewife. And so when I joined second year, my first semester, my mom introduced me to Lab Trust after she received some phone calls from my dad's workplace. And so we went with her because I'm usually here in Nairobi. So when we went, they assured me that they were going to pay my school fees and I didn't have to worry. So that was like a saving grace for me. And since then, my school fees has always been paid. My upkeep is always in check and my house is always in check. I've never lacked anything since then in second year, and up to now I'm in my 4th year, final semester. And as you can see, due to lab trust, I'm able to carry on my project. Here is one of them, and I'm studying the plant diseases, and I'm using a treatment known as silicone. Then I'm controlling the disease to see if it is going to be controllable. And this has become my passion, and I love agriculture so much. Right now I'm in my final semester, and by next year in January I'll be done with school. And my plan is, if I'm going to get a job, I can join the scheme, the lab trust scheme, and ensure even if when I'm going to have kids later in future, their lives are going to be catered for even in my demise, because CPF has done that for me, and I'm very grateful, because if it weren't for them, I don't know if I could be even here in school. And thank you so much, CPF, for fulfilling our lives. I have 2 sisters at the moment, one in college and the other one is in grade 4 in primary school, and they have been paying for their fees as well. And we can say our life has never been the same, and we are so happy for CPF and how they have helped us. And thank you, CPF, for fulfilling our lives and making us smile again after everything.